In last class, we completed the divide and conquer introduction. Now we will see divide and conquer applications. What is the meaning of divide and conquer application? Using divide and conquer abstract algorithm, right? How to solve the problem means few problems I will explain to you, which are there in the GATE syllabus, right? Those problems I will explain. I am repeating once again. Now I am going to explain in this class divide and conquer application, which is nothing but using the divide and conquer algorithm, right? Few problems I will solve. Few problems I will solve, right? Please be careful. And one more thing I want to ask you. Using divide and conquer algorithm, right? 10 crore problems are solved. I cannot explain all. The things which are there in the GATE syllabus, I will explain. Right? Let me write now. Right? Let me write. Divide and conquer applications. Divide and conquer applications. See this one. Right? First one. Divide and conquer application. First one. Finding maximum minimum. Finding maximum minimum. Maximum and minimum. Divide and conquer applications, right? First application is finding maximum minimum. In the previous paper, right, many times this question is came. That is the reason I want to explain using divide and conquer algorithm how to solve this problem. Many applications are there. Even 10 crore, maybe 100 crore applications may be there. Right? I cannot explain because everyone know divide and conquer is a one template. Using that template, many problems you can solve. Right? The things which are there in the previous paper, those I will explain. If anything new will come, mostly new will not come. If anything new will come based on the things which we covered in the classroom, you have to complete by yourself. Please be comfortable whatever is going on in the classroom without by hearting. It is the first application of divide and conquer. Right? So the second application, many there. Second, power of an element. Power of an element. It is second application. Third application, binary search. Fourth application, merge sort. Fifth application, quick sort. Sixth application, selection procedure. Seventh application, Strassen's matrix multiplication. Eighth application. Sixth one is selection procedure. Seventh one is going to be Strassen's matrix multiplication. Right? Eighth one, continuous maximum subarray sum. Maximum subarray sum. Continuous maximum subarray sum. That is the eighth one. Ninth one, quick sort, selection procedure, Strassen's matrix multiplication, continuous maximum subarray sum. Next one is going to be one more, counting inversions or finding inversions. Many applications are there. These 9 applications mostly I will explain to you. These 9 applications. What are the first one? Finding maximum minimum. Second one is power of an element. Third one is binary search. Fourth one is merge sort. Fifth one is quick sort. Sixth one is selection procedure. Seventh one is Strassen's matrix multiplication. Eighth one is continuous maximum subarray sum. Ninth one is going to be counting inversions. Right? These are the applications. So let's take one by one. Right? We'll continue. Right? All these applications. These are the application of divide and conquer. And one more thing I want to. I'm starting now. See this one. To solve all these things, basics really required. That there is all the basics I covered. Every basic point I covered clearly. One place also I didn't done any shortcut. All basics I completed. right? If anyone is not comfortable, the basics which I covered until now, please revise once again. Please don't decrease yourself. I'm repeatedly saying to you, if someone is not comfortable, any one of the lecture which has happened until now, please revise. I think according to MEDISI rules and all, right, maximum 3 times maybe you can do, right? 3 times maybe you can watch. So while doing first time itself, maybe you have to make the notes, right? Afterwards, right, do yourself. At anywhere trouble is there, right, you can go through that point and you can handle it, right? You please be careful. At anywhere, if you are not comfortable, don't think that you only not comfortable. Many people are there. First, I am not comfortable few years back. I practiced, finally I am comfortable. Right? If any student asks me very difficult one, right? Sometimes I will also struggle. After all, everyone is a human being. You may be thinking that you only struggling. Everyone is struggling. But not only struggling, right? You have to take care, right? Where you are, first of all, identify where you are struggling. Right? Next one, through the videos, whatever you are watching, through that videos, is it possible or not, please verify. If not, open the standard book, whatever I said. So always try to remember this one. If whatever will happen, take it positive. Something is keep on troubling you, right? Please spend more extra time. Don't cry. Crying cannot solve any problem. Crying unnecessarily create a lot of trouble to you. Anywhere if you felt that some problem is there, right? Please spend more time. Someone is studying 1 hour, right? He is not troubling, but you are studying one hour. Isn't that you are troubling, right? Try 1 more hour. Try 1 more hour. So like that you can manage. Please be careful at the end of the when you say GATE exam is over, right? I am really saying to you should be comfortable with algorithm subject. This is the major goal. If you are comfortable with algorithm subject, mostly you done the justification to the GATE preparation, whatever you done. So I am starting now. See this one. So divide and conquer applications many there. First application I am starting. All basics, almost I done all the basics. 1 or 2 doubts are there. Again they will come. You will be comfortable. But assume that, listen, I am starting now. Before going to start, I am reminding you one line. Assume you are comfortable all the things whatever happened until now. Assume that. Even though if anyone is not comfortable until now, assume you are comfortable, now start. At least be comfortable from now onwards, because the things which I have done until now, they may come once again. I will make sure that you are comfortable. Assume you are comfortable, concentrate here. Concentrate. What is the first application? Finding maximum minimum. Let me write now. Finding maximum minimum. Finding maximum minimum. This problem using divide and conquer we have to solve. I will solve now. Nothing there, I will solve. See this one. To this problem you only say, to this problem input. To this problem input I am writing now. What is the input to this problem? Finding maximum minimum. What is the input? Everyone now. Input is going to be an array of n elements. An array of n integers. That is the input. Input is going to be an array of n integers. Output is going to be, right, find or return. Let me write return. Return maximum element in that and minimum element. Return maximum and minimum elements from that. This is the input and output. Finding maximum minimum is the application name. Input is going to be an array of n integers. Output is going to be return maximum element and minimum element. So, right, this is the problem. And one more thing, let me say again. Many times I said to you, again I am saying now, one more thing. Please listen this, please listen. So, when you are studying algorithm subject, right, don't say I am not comfortable algorithm subject. Don't say like this, right? Say this topic I am not comfortable. Don't say like that also. In this topic, right, problem number 5 I am not comfortable. In the topic number 3, problem number 2 I am not comfortable. Please say like that, then people will listen. Suppose assume that one of your friend is there, you also listening this lecture, your friend also listening the lecture. If at all he will come one day and he said to you, algorithm I am not comfortable. If at all he will say to you like that, please slap him directly. Please slap her directly. Right? So after watching these videos, right? You and your friend both are watching, right? One day your friend came and he is saying that I am not comfortable with algorithms. Please slap directly. If they ask why are you slapping, slap again. The reason is he cannot say like this one, right? He have to say. Topic number 3, problem number 5, I am not comfortable, right? Please explain, then encourage. Good things, please encourage. Bad things, please punish. Right? If you don't punish the bad things, next day again he will come. He will say, I am not comfortable with you. Previously, he is not comfortable with algorithm. After next day, he will come because of your encouraging bad thing. Next day, he will come. He will say, I am not comfortable with you. I am not comfortable with your family. I am not comfortable with India. I am not comfortable with this world. He will say a lot of bullshit. Please be careful. If anyone want to say, right, this is not comfortable, but say in the nice way. Right? In algorithm subject, first topic is finding time complexity. I am comfortable. Second one is asymptotic notation. I am comfortable. Right? Third one is going to be, right? Right? I think recursion, recurrence relation and all. So I think topic wise you study. First topic is time complexity finding. Second is going to be asymptotic notation. Right? Third one is going to be basics of divide and conquer. Next one is going to be, I think, fourth application. Like that, there is a, right, topic wise I covered. Topic wise, please try to study. If you can do topic wise justification, right, then total algorithm is justified. This is the meaning of divide and conquer. Topic wise, please be comfortable. Then overall algorithm subject you are comfortable. Because of one topic, don't say algorithm subject I am not comfortable. Don't say like that. Everywhere some small doubts will be there. Right? You may be thinking that, right, there is a one person who is so great and all. You may thinking like that. He is also having problem. They may not able to express outside. Everyone having problem. You may be thinking that I don't have any problem in algorithm. I also having some problem. I may not express to you. Next one, one of your friend is there who is so good in algorithm. He is also having problem. Everyone having problem. Right? You keep on rectify. I am rectifying, you also keep on rectify. My teacher also having problem. Everyone have, because they are humans. You are having some problem. If you think that you are having more problem in algorithm, do more hard work. No other way. You cannot escape. Okay, I'm stopping all these things. Now I'm starting. Now see this one. If anyone want to say you are not comfortable in algorithm, don't say like that. Say topic. Which topic you are not comfortable, which problem you are not comfortable. Right? Those only good ways. Don't say some bold statement. I am not happy with India. There is no meaning in that. Right? You cannot say like this. India, you are not happy. You cannot say like that. In India, right? With which person you are not happy? Say like that. Right? I'm really saying to you. Algorithm subject, I am not happy. Don't say. Topics you can say. Nice way you can say. So that some people can help you. If you say algorithm, I am not okay, please explain. Who will explain this? Right? So if you say nice way, people will help you. I'm thinking that I'm stopping this entire nonsense, whatever I'm saying until now. Right? Now let me concentrate now. Please be comfortable from now onwards. Now what is the current topic going on? What is the current topic? Finding maximum minimum. This is only your goal. This is the one topic, right? Isn't that? This is the one topic. Finding maximum minimum. This is the one topic. Just concentrate on that only. Yesterday, divide and conquer, right? Introduction. Please concentrate on that. Which is nothing but recursive program, time complexity finding and all. Yesterday's topic is going to be, right? What is that one? Divide and conquer, introduction and finding time complexity of recursive program. This one is going to be finding maximum minimum. Topic wise you study. Before that, recurrence relation solving. 3 methods. Before that, recursion and recurrence relation. Topic wise, please study topic wise. Repeatedly you do. Don't by heart. Right? I'm thinking, see, and one more, in a particular topic, because of some problem, if you are troubling, don't think that much. It will be clear. Maybe tomorrow, maybe day after tomorrow. Right? So in videos, those people who are watching the video, right below, you can write the comments also. Right? Someday, maybe I will help you also. Worst case, you can ask me, right? You can ask your friends also. You can ask, right? You can see YouTube also. Many ways are there. Many ways. As I'm really suggesting one more thing also. Algorithm subject in internet easily will find the answers. This is the subject which is having the lot of material in internet. But the problem is going to be, right? Many people will write many ways. That is the only problem. If you know 95%, if you don't know 5%, easily you can handle it. Right? Suppose that there is a one topic, 95% you know, 5% you don't know. Mostly internet will help you. Right? You can ask me also. You can see in the right Coreman also. This subject having lot of sources to clarify. If you know 95%, if you don't know 5%, then definitely you can solve it. Suppose reverse happened. What is the meaning? 5% only you are okay. 95% you are not okay. Means go to hell. No one can help you. If you do more work, right? Definitely your neighbors can help you a little bit. Majority things should be done by you only, right? Majority things other people cannot do because of you. You do majority thing, right? Small thing, neighbors can help you. Okay, it's okay. I know very well, right? Whatever I said from the last 5 minutes or 10 minutes, please take only positive points. Just see positive points. Right? Fine. Everyone having drawbacks, just see positive point. Okay, this point is nice. Please take care. Now, can you help me? Forget about all the things whatever happened until now. Can you help me? What is the current topic going on? Finding maximum minimum. Right? I'm starting. Input, an array of n integers. Output, return maximum element and minimum element. Right? See this one. Now, I'm writing. Just let me take one example. I'm taking one example. Input, output I written, I am writing one example also. See this one, input array A which contain I think some numbers. Let's see the indexes, array indexes 1, 2, 3, 4, 5, 6, 7, some numbers. I think these are the indexes, array indexes. These are not the elements, these are the indexes. Array name is what? A. Indexes are 1 to 7. Let me give values. 80, 20, 50, some numbers. 90. Next one is going to be 11, 68, 99, some numbers. So this is the input. Can you help me now? To this input, right? Can you say what is the output? Everyone know. What is the output? In this array, you have to find out maximum element, minimum element. Let me write. Maximum element you have to find out and minimum also you have to find out. Please give the answer to me. Please give. What is the algorithm? Within few minutes I will explain to you. Can you say roughly in this array, what is the maximum? Just scan one time. What is the maximum? 99. Minimum, scan one time. Minimum, 11. So this is the thing what we are expecting. For this problem, for this input, this is the output. How it will be done? We'll see now. Within few minutes I will explain. But I'm thinking that you are really comfortable. How to find out maximum, minimum, right? So can you help me now? This is the application of divide and conquer. This problem is application of divide and conquer. What is the meaning? This problem can be solved using divide and conquer. That is the meaning. But one thing, I will explain within a few minutes using divide and conquer. But how to solve this problem without divide and conquer? Right? How to solve this problem without divide and conquer? Let me explain, because without divide and conquer, you know what is the answer of this problem. To this problem, without divide and conquer, what is the answer? You know, right? Let me explain. No need to by heart also. Meaningfully you study. Okay, finding maximum, minimum. Right? Without divide and conquer. What is the meaning of divide and conquer? Division should be there. Conquer should be there. Combine should be there. That is called divide and conquer. This problem using divide and conquer, how to do? Within few minutes I will explain. That is a new thing what you study in this particular application. But this problem without divide and conquer, how? I will explain that also. It is really not required because of it the first application. Let me explain. Without divide and conquer, how will you do this? With divide and conquer, how will you do? Let's see that. Because of it the first application. For the remaining application, I may not cover all. Right? Let me explain. How to solve this problem? Without divide and conquer? Let me write. I am writing now. See everyone? Without divide and conquer. There is no division here. Without divide and conquer. How to solve this problem? I will do roughly. See this one. I will do roughly. See, this is the way. Everyone listen. This is the way. For I is equal to 1. Can you help me? This array contains how many elements? 7 elements. This array contains 7 elements. This one. right? This array contains 7 elements. In this array, I want to find out maximum element also, I want to find out minimum element also. Please be careful. In this array, I want to find out maximum, I want to find out minimum also. See how I am doing. Array contains 7 elements. See the answer. For I is equal to 2. Why 2? I will explain to you. For I is equal to 2. I less than or equal to n may be 7. Next one, I plus plus. I is equal to 2, I less than or equal to n, I plus plus. And one more, see this one more. Before starting this for loop, it is the for loop. Before starting this for loop, just let me write one line. See this one, max is equal to, min is equal to, a of 1. Right? Assume that first element itself, maximum and minimum. To this algorithm, see, without divide and conquer, I will solve this problem. This algorithm you know very well. Normally we know without divide and conquer only. Whatever you know, that only I am saying now. Very simple. Just consider first element itself is everything. So first element itself is maximum also, minimum also. Can you help If the first element itself is maximum and minimum, then what is the meaning? Let me check this one. Let me run the algorithm. I am expecting to this input, this output. Will I get or not? If you want, you can check. See this one. Maximum is equal to, minimum is equal to first element. Who is the first element? 80. 80 is everything. Maximum and minimum first element only. That's fine. Right? This itself is the, see this one, this element itself is the maximum and minimum. Remaining element, who are those? Right, totally actually 7 elements are there. First element itself is maximum, minimum. Now 2 to 7 elements, means which means 6 elements are there. Now loop is going on. See this one, in this loop what they will do? Loop is going on. Carefully listen. I is equal to 2. Next one it will become 3. Next one it will become 4 and so on. I value, right? I think n value 7 everyone. I is going on, something like that. Right? Please be careful. This is the current status which is going on. Now see the answer. I is equal to 2. See what he will do. What is the maximum, minimum? Right? Maximum, minimum as of now first element. See the answer what he will do. If, see everyone now. If a of I, what is the I? 2. What is the a of I? 20. I is 2. What is the a of I? 20. See this one. A of I is 20. Right? A of I is 20. See everyone now. A of I is 20. If a of I is greater than max. Comparing the existing max, A of I is maximum. Then comparing A of I and maximum, A of I is maximum. Then what is the answer? Max is equal to, what is the answer? A of I. Comparing the A of I and maximum, A of I is bigger, then max will change. Right? Some people are asking, suppose that A of I is more than maximum, then maximum will change. Next one, right? Next I value becomes 3. A of 3 is greater than maximum, then maximum will change. Like that it is keep on going. Supposition that A of I is greater than maximum, fail. Then what is the meaning? If A of I is greater than maximum, fail, indication, that's this one. This is fail means else. If it is fail, then only come. If it is pass, don't come. A of I is greater than maximum, then max is A of I. Else what will you do is, listen, don't change immediately minimum. Then you have to check this also. What is the answer? If A of I is, what is the answer? Less than. If A of I is less than minimum. If A of I is less than minimum, what is the meaning? Comparing minimum, A of I is less, so then min is A of I. Then min is A of I. This is going on like this. Lastly, return maximum, minimum. If you want, you can write that line also. Return max min. Return maximum, finally minimum, whatever is there. Don't bother about syntax error, semantic error. This is the algorithm for that. Right? Can you help in this algorithm? Please help. For loop is how many time? 2 to n. What is the meaning? N minus 1 times loop is going on. Right? So I is equal to 2. First element itself is maximum, minimum. Second element onwards, keep on comparing. The element which is coming is more than max, then maximum will change. The element which is coming is more than max, then maximum will change. The element which is coming is not more than max, so then I have to ask, is it less than min? Then change. Suppose that the element which is coming more than max is fail, less than min also fail, then don't change. then don't change. So some people are thinking that max not changing means they will think that minimum is changing. May change, may not change. Sometimes no one will change. Right? So there is no chance of both will change. Either this will change or this will change. Sometimes both may not change also. Right? Please be careful. So max, I think more than max coming, then change the max. Otherwise, just ask. Less than minimum is coming, then change min. Right? Like that, continue. How many times? N minus 1 times. N minus 1 time. This is the algorithm. This algorithm you know very well. Though if anyone having small doubt also, I will start now. Same algorithm, whatever I written on the board, I will implement here. See this one. I think I value 2, A of 2, 20. Can you help me now? 20 is more than max. No. Then asking, 20 is less than min. Yes, then change it. 20 is more than max. No. Then asking, 20 is less than min. Yes, then change it. So, I value 2 completed. Next one, I value 3. A of 3, 50. Let's ask. 50 is more than 80. No. 50 is less than 20. No one is changed. Next one, 90. Come here now. 90 is more than 80. Yes. If he changes, no need to ask him. If he is passed, no need to go else. Next one, I value 5. A of 5, 11. 11 is more than 90. No. 11 is less than 20. Yes. See, so if the first one pass, no need to go to second. If the first one fail, then ask second. Ask second, don't change. Ask second. Second saying that yes, then change it. Next one, I value 6. A of 6, 68. 68 is more than 90. No. 68 is less than 11. No. 99. 99 is more than 90. Yes. When if is passed, then don't go to else. Can you help me? This loop is how many times? N minus 1 time. So can you help me at the end of this loop, at the end of this entire story, loop is over. So, sorry for this one, this may be the line, sorry for that. Sorry for this one, just a small change. Same thing only. Right, this is the case. This loop is going on N minus 1 time. After this loop is over, in this loop, whatever is maximum minimum, that one you return. Return maximum and minimum. And one more. See, carefully listen. This loop is N minus 1 time, that is fine. This loop is N minus 1 time, that is okay. Right, this loop is N minus 1 time. After N minus 1 time is over, whatever is there in maximum minimum, return it. That's okay. Now listen. This entire story, whatever we done, that is called as that name they are given. Straight max min. Straight max min. Algorithm name straight max min. Straight max min algorithm. What is the input? Array A which contain I to j elements. Or array A which contain n elements. It's up to you. Array A which contain I to j elements. If you want, you can write n also, no objection. Both are same. Array A which contain n elements. Right? So what is the name of this algorithm? Straight max min. Input is going to be array A which contain n elements. This algorithm is running like this. Right? Lastly, right? This is the end of this. Can you help me? Why this algorithm name is straight max min? Without divide and conquer, you are finding maximum minimum. Now, if anyone asks you from now onwards, please explain how to find out maximum minimum without divide and conquer. What is the first step? Without divide and conquer, you want to find out maximum minimum. What is the first step? Everyone know this. It's a very simple algorithm. One scan. While scanning, please be careful. How to do that? First element itself assume that maximum minimum. Second element onwards, start the loop. Every time, whenever this loop is going on, every time ask the maximum person. If the maximum saying yes, then change it. Maximum saying yes, then change it. What is the meaning of maximum saying yes? The person who is coming is more than max. Max saying yes, then change it. Suppose maximum saying no, I don't change. Then ask the minimum, will you change or not? If he say yes, then change it. If he say yes, then change it. Right? Like that. So sometimes both will say no, then don't change. Sometimes only first one say yes, so if the first one say yes, don't go second. Because else there in between. Right, like that. This card. What is the name of this algorithm? Straight max min. Why? There is no division here. See, there is no divide and conquer. Divide and conquer means divide will be there. Conquer will be there. Combine will be there. But there is no terminology like that. Simply take one loop, continue. First element itself is maximum minimum. With that, compare other people. Can you say loop is going on how many times? N minus 1 time. This is called as straight max min. Can you say what is the problem name? Finding max min. What is the input? One array. Output, find maximum minimum. How to solve this problem? Without divide and conquer also you can do. Many ways, many ideas are there. Some people are thinking that, right, without divide and conquer, this is the only way. No, different people will write different ways. Whatever I written, I am explaining, right? Through experience, I got not the best algorithm. Without divide and conquer, this is the better approach. Many ways are there. Please be careful. See this one. I cannot write everything here itself. I cannot confuse you. Best things I written. Mostly whatever I will write in this classroom, all the best things I will write. All the best things I read. Finding maximum minimum without divide and conquer, this is the thing. Right? If you see some other way, some more algorithms may be there. That is also right, this is also right. Please practice this only. Without divide and conquer, this is the idea. Right? I am thinking that you are really comfortable. Right? Let me ask you one small line. Now problem is clear. To this one straight max min algorithm also clear. That is fine. Now please help me. See this algorithm and talk. Without divide and conquer, finding maximum minimum. See this algorithm and talk. Can you help me one small line now? In this algorithm, if you observe, loop is how many times? N minus 1 time. In this loop, if you observe, two conditions are there. First condition, second condition. Two conditions are, see, here one comparison. In this algorithm, if you observe, so between the elements only we are talking between the elements only, not these. It is the for loop, leave it. Between the elements only we are, see this one. Here one comparison between the elements, here one more comparison between the elements. Can you help me? This loop is how many times? N minus 1 time. How many comparisons are there? Two comparisons. If the first comparison true, no need to go to second. If the first comparison fails, then only second. Right? I think this loop is going on n minus 1 time. This loop is going on. Two comparisons are there. That is also okay. Right? Let's see this one. Can you help me one small line now? Right? Whenever this algorithm is running, you only say, right? Minimum number of comparisons how many? Whenever this algorithm is going on, minimum number of comparisons how many? Between the elements. We are thinking about between the elements only. Between the elements. Number of comparison, these also will come. What is that one? I less than or equal to n, that also will come. Number of comparison between the elements. Please be careful. Whenever this algorithm is running, between the elements, how many comparison? Let me check. What is the answer? Supposition that if you are lucky, every time you will come here, this is true. Right? Every time you will come here, this is true. So whenever this algorithm is going on, minimum number of comparisons are going to be, what is the answer? Each I value, first one compare, true, stop. Each I value, first one is true, then stop. I think this algorithm this loop is going on n minus 1 time. Every time first only pass, right? That is going to be minimum number of comparisons. Right? Let me write here. See this one? Tn is equal to number of comparisons between the elements. Tn is equal to number of comparisons between the elements. Assume that. Before going to write itself, I defined first. You always remember what you are going to do. You should have clarity. This is my clarity. See this one. Tn is equal to number of comparison between the elements. Some people are thinking that Tn is always time complexity. No. Whatever way you want, you can use. Tn is, in this story, Tn is going to be number of comparison between the elements. Right? Now, can you help me now? Tn is equal to number of comparisons between the elements. If it is okay, please say to this algorithm. Best case comparisons how many? To this algorithm, best case comparisons how many? What is the best case Tn? Best case Tn, everyone know. This loop is going on n minus 1 time. Every time this is pass. Here itself you can stop. What is the meaning of best case? Best case is nothing but the minimum amount of time required to solve the problem. Minimum time, not maximum, minimum time. When the minimum time will happen? Every time pass, then minimum time. Best case time complexity is nothing but minimum amount of time required to solve the problem. Can you help me now? In this problem, what is the minimum number of comparisons required? Every time come here, this is failed, then only go here. Then one more comparison. Every time pass here only. Why I will go further? So minimum comparison. How many? Minimum is n minus 1 comparison. Minimum number of comparisons required to solve this problem. I think n minus 1. Can you say when the minimum will come? When the minimum will come, I think increasing order. First one is smaller, afterwards all will be increasing. Every time A is bigger, then max will change. So increasing order is coming, then best case comparisons will come. I am writing also, increasing order, best case will come. To this algorithm, see this one. Whenever this loop is going on, minimum number of comparisons are n minus 1. Can you help me now? To this algorithm, what is the maximum number of comparisons, which is nothing but worst case? Worst case comparisons how many? Whenever this algorithm is going on, can you help me? This loop is going on how many times? N minus 1 time. This loop is going on n minus 1 time. Two comparisons are there. First comparison failed, then only second. First comparison failed, then only second. Two comparisons are there. Every time two you are running. That is the meaning of worst case. Worst case means maximum work. Here two comparisons only there. Every time two comparisons are going on. Right? First time this is fail, I will come here. It is fail or pass, doesn't matter because further there is no work. Every time two comparison. So what is the answer? Worst case. Every time two comparison like that n minus 1 time. That is the worst case comparison. The maximum number of comparisons required to solve this problem, that is called as worst case comparisons. Next one. I am thinking that everything is okay. Let's see average also. Average case, how many comparisons? Can you help in how many comparisons are there inside this loop? Inside this loop, two comparisons are there. What is the meaning of best case? Always here you are stopping. What is the worst case? Always here you are stopping. What is the meaning? This is failed, then you came here. This is failed, then you came here. Two comparisons are there. Best case means always stop at first place. Best case will come. Worst case means always stop at second place. But you came through second means first fail. So every time two comparison like that n minus 1 time, that is going to be worst case. But try to remember, average case means best means always here. Worst means always here. Average means off here. Average means everyone. Average is nothing but what? Equal priority. Uniform distribution. That is called average case. Average case is nothing but don't show partiality to anyone. Give chance to every person. Right? Give chance to every person. See, in India, right? Many rich people may be there. Many poor people may be there. But what is the average? On an average, right? Indians are poor. That is why people will use to say that India is poor country. What is the reason? Majority what? Right now, can you help in what? Try to remember. Average case is nothing but don't show partiality to anyone. Average is nothing but mostly what is happening. That is the average definition normally. Most of the time what is happening in this problem. And one more thing I want to say, average case normally no one will ask you because average is based on many people. Average calculation is very difficult also. Problem to problem, average definition is keep on changing. Right? Sometimes average means what? Majority. What is happening. In this, what is the meaning of average? Right? Two cases are there. Right? What is the meaning of average? Equal priority or equal probability or uniform distribution. What is the meaning? Two, right? Off time this. That is called average. Off time this one. That is called average. I am repeating once again. Average defining is very difficult. Problem to problem, average definition is keep on changing. Sometimes average means, right? Majority what is happening. Most of the time what is happening, that is called as average. One more way. In this problem, two cases are there. Right? Average is nothing but half time it is working, half time it is working. That is called as average case. Right? Let me write now. To this problem I am talking. Right? And one more thing. Right? In no examination people will ask average. What is the reason? Average finding is difficult. It is based on many things you have to take care. Suppose if someone asks you, what about on an average, what about Indian population? On an average, rich people or poor people? You have to take everyone into consideration. Finally, you will give average. Average based on all the people. I'm repeating once again. Can you help me now? Best case, this only. Worst case, this only. Always if you show, right, importance to first one only, best case. Always if you show, right, importance to last one, that is something like worst case. If you give importance to both the people, average means you have to give importance to all the people, please be careful. If you give importance to both, that is called average. Right. Let's see the average case. Best case fine, that is okay. Worst case also, that is okay. See the average, see the average. Can you help me know what is the meaning of best case? Here two cases are there. What is the meaning of best case? Always giving importance to first one, best case. Always giving importance to the second one, that is going to be worst case. But when you say average case, try to remember average is not giving to priority to someone, right? Average means you have to take care about all the people. You know how to find out average, right? If the 10 students, average, if you want to find out 10 students, every student marks you take. Add them, divide by 10, then only 10 people average will come in the similar way. What is the meaning of average? Best means you will take this, worst means you will take, average means you have to consider both. And one more, you have to give equal priority. You have to consider both. Can you help Best case means always is working. Worst case means always is working. Can you help this loop is how many times? N minus 1. This loop is N minus 1, right? Best case means only this, worst case means only this, that's okay. See the average. Average case is nothing but, see everyone, average case nothing but, right? Total loop is going on N minus 1. Total loop is going on N minus 1. Half time first one. Half time second one. Half time first one means what? One comparison only, right? Half time second one means two comparison. If you want to come to second one, first one fail, then only you will come to second one, right? So half time first one, half time second one, always first to best to, always last to worst. Average case, half time first to half time last. So this is called average case. Now can you help me if you simplify how much? N minus 1 by 2 plus N minus 1 by 2, I think 2 cancel. Then finally what is the answer? It is going to be N minus 1, it is going to be N minus 1. What is the meaning of this one? It is a half, it is a full. Then what is the answer? 3 into N minus 1 by 2. 3 into N minus 1. Full plus half. Right? 1 plus 1 by 2, which is going to be 3 by 2. 3 by 2 N minus 1. Which is going to be, listen, which is going to be, let me write, 1.5 N minus 1. This is going to be best case, this is going to be worst, okay, this is going to be average case. Everyone know. Best case means minimum time. Worst case means maximum. Average is normally in between. Best case is minimum. Worst case is going to be maximum. Average is in between. Can you help Best case comparison N minus 1. What is the upper bound? For anything you can find out upper bound, N. Worst case comparisons, what is the upper bound? N. Average case comparisons, what is the upper bound? N. Let's see, before going to concluding this one, let's see this one. This program, recursive program or non-recursive program? This program, recursive program or non-recursive program? You know very well, right? Straight max min, not calling straight max min. It is a non-recursive program. Can you help to this non-recursive program? What is the time? To this non-recursive program, what is the time? Everyone know. Time means loops only. I think one loop is there. I think what is the answer? Time complexity of this algorithm. You know very well. Time complexity of this algorithm is what is the answer? See, this loop compulsory. There is no way to stop the loop in between. See, I value 2, it should run 3 also, 4 also, 5 also. What is the time complexity? This loop is how many time? N minus 1 time. Time complexity theta of n. Every case is going to be time complexity theta of n. This loop compulsory. Every time I have to, means maybe this condition or both the condition, but one thing, this loop should repeat n minus 1 time. Right? Time complexity theta of n, everyone know. Right? Everyone know. Non-recursive program, time complex, loops only. Right? That's fine. Can you help What about space? Let's see, space. Right? Space complexity is going to be input plus extra. See, normally extra only important. Please be careful. Input is no one, everyone know input. What is the requirement of writing? But space complexity means total. That's fine. Right? Normally people will ask extra only required. Can you say what is the input? To this problem? What is the input? I written also. To this problem, what is the input? An array of n integers. So n integers means n bytes approximately. An array of n integers, so n bytes. Can you say what is the extra? You only say. It is a recursive program or non-recursive program? Right? Non-recursive program. What is the meaning? I think one function call only. Straight max min. One function call. Right? Because it is a one function call. Right? 1 unit of space maybe. 1 byte. If not 1 byte, 10 bytes. Because some local variables and all. Simply extra space is going to be, because of it is a non-recursion, one function call. One function call means 1 unit. That may be 1 unit. That may be 1 byte, whatever it is. So n byte, 1 byte, finally big O of n. So this is total space, right? Extra space is 1 only. Extra space is constant. People normally will ask extra space only. Space complexity, this is the definition, right? So total is going to be big O of n. Extra is 1, right? Fine. The amount of space you will use, that is called space complexity, input plus extra, right? Extra is going to be 1. If they ask you extra, just say 1. Normally extra only people will ask you. Okay, it's fine. So time complexity you know, theta of n, space also you know, right? This is a non-recursive program, which is the straight max-min. Fine. Now our goal is it with divide and conquer or without divide and conquer? This is without divide and conquer. Let's come to the major story. With divide and conquer. With divide and conquer. I am writing, this is the only thing which is required to us. Finding max-min using divide and conquer, how? That is our goal, right? Let me write now. With divide and conquer. With divide and conquer, how to solve this problem? I will check once. With divide and conquer, how to solve this problem? See the input. Input is the same story. What is the answer? An array of n elements. An array of n integers. An array of n integers. What is the output? Input is an array of n integers. So output is what? Finding maximum, minimum. Same story. Find max, min. How it is using divide and conquer, I will explain now. Please be careful from now onwards. Previous one is without divide and conquer. Please be comfortable previous one also. If not, then also no problem, come here. This is the major story. Our goal is this only. Let me give one example. One example. Array A. 1, 2, 3, 4, 5, 6, 7. 7 slots. Right? Let me give the values. Something you can take. 80, 20, 50, 90, 60, 3, 85, some numbers. This is the array. Right? Can you help me now? To this array. Right? What is the maximum here? What is the minimum here? To this array, what is the maximum? What is the minimum? What is the maximum? I think 90. Minimum 3. To this array, maximum is 90, minimum is 3. How to solve this problem? Using divide and conquer, I will explain. So using divide and conquer. Let me write one interesting line. To this problem, using divide and conquer, what is the answer? Right? I have to give, I am giving now. Concentrate properly. Using divide and conquer, how to solve this problem? I am starting this. Right. Now please give the answer to me. If I want to solve this problem using divide and conquer, you only say what will be the first step. If I want to solve this problem using divide and conquer, what will be the first step? Remember that algorithm, abstract algorithm. That algorithm only. Divide and conquer means that algorithm only. If I want to solve this problem using divide and conquer, right, that abstract algorithm of divide and conquer, please check. What is the first step? Right? Please check problem small or not. Right? Please check problem is small or not. And one more thing I want to ask you. In the problem itself, if at all they mention, right, when the problem is small, just follow it. In GATE examination, suppose assume that this question is came. Finding max min using divide and conquer. If they say when the problem is small, please take it. If they don't say, right, whatever I am saying, follow. But suppose some people are asking, sir, whatever you said, that also we forgotten. Assume. Then what will you do? You take whatever you want, but it should be a constant. Constant element, small problem. I am repeating once again, this problem is given in the GATE examination. They are saying, solve this problem using divide and conquer. Then what will you do is, if you want to solve using divide and conquer, then what you have to do is going to be, right, first check, right, easy given anything, right. If they ask you solve this problem using divide and conquer, what you have to do is, in the problem are they mentioned when the problem is small or not, verify. If they say follow it. If they don't say whatever I am doing, just follow it, because this is there in the previous papers many times, right? This is there in the core man book also. In one of the standard book it is there. Just as it is I am saying. But one thing, when you forgotten, suppose unfortunately you forgotten, assume, right? You take whatever you want, but one thing, constant elements you have to take, then it is called small problem. Can you help me now? Finding maximum minimum is small problem, right? This is the case. Let me write here. See this one, small. Whatever I am saying, just remember. If they say something, follow. If they don't say, just write whatever I am saying, just follow. According to this problem, this is going to be small problem. One element is there, small problem. Array contain one element, small problem. Array contain two elements, then also small problem. This problem using divide and conquer is small problem. One element is there or two element is there. Some people are asking, if one element is there, how small problem? You only say array contain one element. You want to find out maximum, minimum. How many comparison? No need to compare. That itself is maximum, minimum. So what is the answer? No comparison. Zero comparisons. One element, just return that element. That itself is a maximum, that itself is minimum. Suppose two elements are there. Two elements are there. Just to do one comparison between them. Then whoever is maximum, that is the maximum. Right? Next one is minimum. So one comparison. So small problem according to this one element or two element, two cases. One element, zero comparison. Two elements, one comparison. Now can you help me solve this problem using divide and conquer? First step. Check problem is small or not. If we given the problem small, follow it. Otherwise, whatever I am saying, just follow. Right? If you forgotten, unfortunately, if you forgotten, right, then you can also do like this one. One element or two element is a small problem. But one thing, just remember, right? Just please give concentration, whatever I am saying. This one you have to follow. Because it is there in the syllabus, right? You have to follow. If new things are given, the things which are given in the syllabus, I will explain clearly. Right? If new thing came, assume that new thing came, you want to apply divide and conquer. If they say small, follow. Otherwise, just take some constant like this. One element is small problem. How many comparison? Finding maximum. No need to compare. Zero. Two element is a small problem. How many comparison? Finding maximum. One comparison I have to do. One. Right? If some other new problem, just to take whatever you feel constant. But one thing, take correctly. Take correctly. Constant elements, right? Take correctly. Right? Fine. I am stopping. I am saying to you. Solve this problem using divide and conquer. First step. When the problem is small, I written already. Suppose problem is big. Suppose problem is big, assume. Right? I think you have to divide. Suppose problem is big, you have to divide. Some people are asking, sir, how to divide? You know divide and conquer strategy. If the if condition true, then return the solution. Otherwise, also. First step, divide. Some people are asking, sir, how to divide? How to divide? Some people are asking, sir, how to divide? If new problem will come, right? Divide whatever way you like. If he says something, follow it. If he don't say, just to do whatever you understood, right? Based on that, right? This problem given, just to do like this. This problem is given, just to do like this. If he says something, follow it. If not, follow my thing. See the divide. If at all problem is big, how will you divide? Very simple. Can you help me now? First element position is 1. Last element position is 7. What are the 1 plus 7? 8. By 2, 4. Right? This is mid. Right? Based on the mid, you divide. Mid element is 4. 1 plus 7, 8 by 2 means 4. Mid is 4. According to 4, you have to divide. Just find the mid element according to mid divide. So that's how this problem is happening. Now I will solve it. I will solve. See this one, solve this problem using divide and conquer. Small, I said. If it is big, how will you divide? I said according to mid. What exactly? With the help of this numerical example, I will try. Right? With the help of this numerical example, I will try. Let me check here. These are the elements. Right, these are the elements. So let me try this. I am trying. Please see everyone. See everyone now. Array contain how many elements? See this one. Array A, which contain 1 to 7 elements. You want to find out maximum. You want to find out minimum. That is our goal. Array A, which contain 1 to 7. In that, you want to find out maximum. You want to find out minimum. How it will be done? Can you help me now? Can you check first? Is it small problem or a big problem? Divide and conquer. Yesterday lecture, whatever I said, same abstract algorithm apply. Let's start. Array A, which contain 1 to 7. What are the one? First element position. What is 7? Last element position. Right? 1 to 7 means how many elements are there? 7 elements are there. This problem is a big problem or a small problem? One element or two elements, then small. Otherwise big. It is small problem or big problem? Big problem. Then you have to divide. How to divide? Find mid element. What is the mid element? 4. Right? According to mid, you divide. What is the meaning? Mid element 4 means array A, which contain 1 to 4. Find maximum, find minimum. Left half. Right? So mid element means what? By 2 means what? 2 parts he is doing. So mid is 4 means what? Array A, which contain 1 to 4. In that, find maximum, minimum. What is the remaining element? Array A, which contain 5 to 7. In that, find maximum, find minimum. Like that. This is the divide. So if you want to solve this problem, because of it is a big problem, divide into 2 parts. Right? After getting left answer, after getting right answer, combine them, you will get the final answer. Some people are asking, after getting left answer, what is the meaning? 1 to 4 find max min. 5 to 7 also find max min. Then combine, you will get the 1 to 7 max min. And some people are asking, sir, this is a big one, you divided, it's okay, but this is also big. If it is also a big, recursion will take care. What is the meaning? Again same. Is it small or big? Big. 1 to 4 means what? 4 elements are there. Again, what is the answer? If it is big, again divide. What is the answer? Mid element find out. That is the meaning of recursion. Can you say what is the 1 plus 4? 1 plus 4, 5. 5 by 2, 2.5. 2.5, should I take 2 or 5? Should I take 2 or 3? I am repeating once again. 1 to 4 elements are there means 4 elements. You only say, if at all 1 to 4 elements are there means 4, what is the mid element? 1 plus 4 by 2, which is nothing but 5 by 2, 2.5. Take 2, 2.5 if at all will come, take 2. Take 2. Some people are asking, if 2.5 will come, why should I take 2? This mid is an integer. At the end of the day, it is a program. Right? At the end of the day, it is a program. Just take mid element, 2.5 is 2. So let me write now. 1 plus 4, 5 by 2, 2.5, just take 2. Array A which contain 1 to 2, find maximum, find minimum. Similar way, array A which contain 3 to 4, find maximum, find minimum. Right? Same thing here also. Can I say 5 to 7, how many? 5, 6, 7, 3 elements are there. 5, 6, 7, 3 elements are there. Is it small problem or a big problem? Big problem. Not one element, not two element. 1 or 2, then only small. Otherwise big. So 5 plus 7, 12 by 2, 6 there. So array A which contain 5 to 6. Find maximum, find minimum. What is the one more? Array A which contain 7 to 7. Find maximum, find minimum. Like that divide. Divide until one element will come. Can help you now. Array A which contain 1 to 2. Is it small problem or big problem? Small problem. Stop. Next one. Array A which contain 3 to 4. Is it small or big? Small. Stop. 5 to 6. 2 elements small. 7 to 7. 1 element small. Right? Like that. Stop. I am thinking that you are almost comfortable. Right? Fine. This is the way. Divide. Why you are dividing? Because the problem is big, you dividing. Why you stopped here? Problem is small. That is the reason you stop. This is the meaning of divide and conquer. Everywhere same story. Problem small, no, then divide. Next one. Problem small, no, divide. Problem is small, no, divide. Like that. Next one. Problem is small, yes, then solve the solution. Problem is small, yes, then solve the solution. Like that all. And one more thing I want to ask you, see this one. Every recursive program behavior you can write in the form of a tree. This is called recursive tree. Every recursive program, so every circle indicate function call. It is, right? Every circle indicate function call. Can you see how many function calls total? I think 3 plus 4, I think 7 function calls. It is a recursive program. Recursive program, if you give 7 elements to this recursive program, internally it will call almost like 7 function calls. Can you say who called, right? Who will start first? He will start. Because of it is a very big, it cannot solve directly. He will call 2 people. Right? So first he will call, because of it is a very big problem, it cannot be solved directly. It will call 2 people. It will call 2 people, it's okay. But first he will call, because first left person will be called first. After left, then right. Some people are asking, why left person first? In the program, he came first. Can you help in the entire tree? It is a recursive program. It is a recursive program behavior. In the entire tree, who called first? First one. But to complete this one, both the children is required. But which child required first? Left child. Why? Left child is nothing but in the program first person. Left child over, then right. Next one. But to complete the left one, again there 2 children are required. First left child, I think he. Right? What is the meaning? First he will call, he will internally call this person. This is over, then this. But to complete this, right, those 2 children, first one required, this one. So let me give number also. Who called first? Let me give numbers. Right? First he will call, function call 1, C1. To complete this one, both required. First E required, C2. After this only this one. But to complete this one, these 2 required. It is a C3. This one, no, don't call anyone because it can be solved directly. It is a C4. After this he will come. Right? Because of he also don't call anyone, so this is also over. Not calling anyone means what? He will complete. He completed, then he will come here. Not calling anyone means what? He will also complete. These 2 over, then he over, then he will go here. It is C5. It is C6. It is C7. Right? Like that. C1, C2, C3. It is the first function call in this entire recursive program. Everyone is a recursive call. Calling, right? Until this problem is over. He will call first, but to complete these 2 required, first he required. To complete this one, these two required, first A required. After this one over, then this. This is also over means both are over, then parent is over. Because if E is over, E will start. C5, C6, C7. Right? Let's see this one. See the interesting answer? See the interesting answer? What is the function calling? I am writing here. See, function calling. Function calling. What is the order? C1, C2, C3 and so on. C7. This is a function calling. Which is also called, listen, I am writing carefully. See, function calling. This is also called as, this is also called function calling. This is also called as pre-order. Pre-order. Can you say what is the meaning of pre-order? Pre-order is nothing but first root, after root over left over, then right. Please be careful. It is the C1, first root, right? After root, left over, then right. So root, left, then right, right? So after root, what is the answer? Left over, then right. But to complete this one, again same. Root, left, right. Left, afterwards, right. Because of these two over, this is over, then this will come. This is called pre-order. What is the meaning of pre-order? Root, left, right. Root, left over means you have to complete this left also like that. Recursion. Whatever you will do this level, same thing further also. From today onwards, if anyone asks you, in every programming language, what will be the function calling order? What will you say? Pre-order. What is the meaning of pre-order? First root, left, then right. First root, then left subtree. If instead of saying left, first root, then left subtree, then right subtree. Left subtree means he will take care about their children also. That is the meaning of pre-order. Remember this one. In every programming language, function calling sequence is pre-order. Right, that's fine now. Now can you help me now? You only say in this diagram, you only say this line also. In this diagram, can you say, can I complete? E will call first, it's okay, but E will complete first. This will start first two. But to complete this one, who required? These two required. First E required. To complete this one, who required? These two required. First E required. Can you help me in this entire diagram? Who will complete first this? Right? Without this, E cannot. That is the reason. Without this, E cannot. E will start from here, but first E will complete. Can you say who will complete first two? C3. After C3, next one, C4. After C4, these two over, then parent over, C2. Next one, because of it is over. To this one, left over, then go right. But to complete this one, these two required. What is the next one? C6. Next one, C7. Next one, C5. Next one, lastly, C1. Right? First he will complete. After left over, then right he will complete. These two over mean this is over. Similar way. First he will complete. Afterwards he will complete. These two over mean this will over. These two over mean this will over. This is called function execution order. Function execution order. It is a function calling order or function calling sequence. If you want, I will write function calling sequence. It is a function execution order. Can you help me? What is the function execution order? See this one. Both the children's over, then parent over. Both the children's over, then parent over. Both the children's over, then parent over. This is called post order. Another name for this one, post order. Every recursive program behavior you can mold in the form of a tree. Now after drawing the tree, I want to explain now. Right? What is the function calling sequence like this? Function calling sequence, okay. What is the execution order? Execution is nothing but children's over, then parent. So some people are saying that parent over first. No. If the parent over first, then what about remaining? Then why you return the remaining things? To complete parent, children's required. Without children's completed, parent cannot. To complete this, these two required. First E required. To complete this one, these two required. Right? First E required. I think to complete this one, no one required. E will complete. E will complete. Then E will complete. E will complete, then E will complete. These two over, then E will complete. This is called function execution order, which is the post order. This is the order. C3, C4, C2, C6, C7, C5, C1. This is the function calling sequence. Function calling sequence, which is called pre-order. Please be careful. Whatever you got, it's okay. Now listen, because of you are really comfortable, I am starting now. One interesting story coming. Please listen. Please listen. Make sure that everyone listen. I am just minimizing also. so that you will get the more clarity. See this. These are the elements. These are the elements. Now you say, one interesting line is coming, try to get as much as possible. Try to get as much as possible. Please say, whenever recursive program is going on, which data structure you are using? Stack. Whenever recursive program is going on, which data structure you are using? Stack. Some people are asking, why stack? Why should I use stack? What is the reason? Many functions are calling. If you don't use any data structure, all these function calls may be, right, may be thrown out. Definitely, you may not get the answer. Recursive program is going on means many function calls will be there. If many are coming, you have to keep in some data structure. In proper order, stack is the best one to execute the programs. Right? You have to keep in the stack data structure. We are using stack data structure. Please be careful. Now, can you see this diagram and talk? See this diagram and talk. Can you say in this diagram, who called first? Make sure that everyone listen. In this diagram, who called first? Who called first? C1 called first. Calling means what? Push operation. In this diagram, C1 called first. Can you help me now? To complete C1 is called first, it's okay. To complete C1, who required? C2 also, C5 also. But who required first? C2. So C1 will call C2. C2 over, then C5. Please be careful. To complete C1, C2 required. Actually, C2, C5, first C2 required. To complete C2, who required? C3, C4, first C3 required. So like that, see this one, he will call this person, he will call this person, like that, is keep on coming. First he will call him, next he will call him, like that. So it is the current status. Can you help me now? To complete C3, who required? To complete C3, who required? I think no one required. If no one required means you can finish it. Because if it is a small problem, no one required. C1 is waiting, why? C2 required. C2 is waiting, why? C3 required. C3 don't wait because no one required. To complete C3, no one required because it is a small problem. If it is small problem, you can solve directly. Some people are asking, sir, how to solve? I am solving now. See this one, array A which contain 1 to 2. Array A which contain 1 to 2. Right? I think 1 to 2 means what? I think 1 to 2 elements are there. Let's go to the 1 to 2. Right? Array A contain many elements. 1 to 2 means these two. These two. Can you help me now? Two elements are there to find out maximum, minimum. How many comparison? One comparison. Just to do one comparison. After doing one comparison, you say what is the maximum in these two. One comparison required. What is the maximum? 80. Minimum 20. So because of it is a small problem, directly you can solve. So maximum is 80, minimum is 20. I think it is completely maximum is 80, minimum is 20. So that indication that it is a small problem, directly you can solve with one comparison. Yes, I done. Because of it is done. Right? Cancel it. Which is nothing but pop from the stack. Over means pop. Right? Calling means push. Over means pop. Yes, it is over, pop. It is over. What is the answer you got? I think from this group, maximum is 80, minimum is 20. Now, can you help me now? To complete C2, who required? C3 required, C4 required. I think C3 is over now. To complete C2, C3 required, C4, C3 over. But C3 over, it's okay. But gap is there. This place you can use for C4 also. You done the push because of C3 is popped. That place C4. Try to remember siblings will take same slot. To complete C2, C3 required. Yes, it is done. It is done means it is popped out. That place C4 also required. Then push the C4. Can you say what is the C4? Go there. C4 is A34. Go there. 3, 4. 3, 4. I think it is also small problem. Can you say what the maximum? 90. Minimum 50. Because of it is also completed. It is also completed. Let me write now. Maximum is 90. Minimum is 50. It is completed pop. Which is nothing but you can pop here. Can you say to complete C2 who required? C3 required, C4 required. I think both are now completed. Means both are available. So to complete C2, C3 required, C4 required, both are available now. Now it is the correct time to complete C2. Until now C2 waiting for these two. Because of these are over, you can do C2 now. Let's see how the C2. Can you help me now? To complete C2, left required, right required. I think left available. Left maximum is 80, minimum 20. Right hand side maximum is 90, minimum is 50. Can you say in this group maximum 80? In this group maximum is 90. Overall what is the maximum? 80, 90, maximum is 90. Overall is 90 maximum. Next one, in the left group minimum 20. In the right group minimum 50. Overall what is the minimum? 20. This is called as combine. So this one, left sub problem completed. Right sub problem is completed. So division is done. Left one is completed, right one is completed. Now combine it. Combining is nothing but left group, right group, maximums compare. Whichever is the best one, take it. Left group, right group, minimums compare. Whichever is the minimum, then take it. So just when you combine it, you got the C2. C2 completed. Right? C2 you can cancel, which is nothing but these two you combined. If you combine these two, 80, 90, maximum is 90. Next one, 20, 50, minimum is 20. Like that combine happened. So in this area, see this one, in this area, divide is done, conquer is done, combine is done. Some people are asking, so then divide and conquer is over. In this area, it is over. Here also it should be done. Overall should be done. I want final answer. Until now, only few things are over. Some people are asking, until few things are over, it's okay. But how I know? How much over, how much not over? This stack will say. This stack will say how much over, how much not over. Please be careful. This stack will say. Can you help me know? By seeing stack, please let me know. Can you say who is the top of the stack in this? Right? Because of they deleted, top of the stack is C1. Can you say top of the stack is C1, indication that whichever is top of the stack, he will be done. Can you help me know? To complete C1, who required? C2 required. Yes, done. Available. To complete the C1, C2 required. What is the one more thing required? To complete C1, C2 required. C5 also. Because of C2 over, C5 call. Next one. To complete C5, who required? To complete C5, who required? C6 and C7. To complete C5, C6 and C7. First, who required? C6. Right? It will be there. Try to remember, parent and child, one level differ. Child will be there, whereas parent is there in the level 2 means, right? Child will be there level 3. Parent and child will be one level. And one more, all siblings will be in the same level. Siblings will be in the same level. Parent and child differ by one level. Parent is there in the second level. Child is there in the third level. Right? Please be careful. To complete the C1, C2 required, completed. Then C5 required. To complete C5, C6 required, C7. First C6 required. But to complete C6, no one required. So E will be done. What is the C6? A56. This. A56. Can you see in the 5, 6? What is the maximum? 60. Minimum 3. Alright, let me write now. 60 and 3. TC is completed. Means pop. Can you help me now? To complete C5, who required? C6 required, C7. C6 over. Then C7 he will call. Right? What is the C7? A77 means this one. Can you say only one element is there? What is the maximum? That itself. Minimum? That itself. This also completed. Let me write. 85, 85. Maximum, minimum, that itself. It is also completed. Means pop. When you say that both the children are over, then I can get the parent. Can you help me now? Left best to 60. Right best to 85. Overall best to 85. Next one, left minimum 3. Right minimum 85. Overall minimum 3. That indication that parent also completed. Means this also completed. Now can you help me now with the top of the stack? C1. To complete C1, who required? C2 required, C5 required. I think both are available. To complete the C1, right? C2 required, C5. I think both are available. I think C1. This also available. I think this merging is completed. What is the answer? If you combine this. If you combine left 60, 85. 85. Left 3, right 3. Right 85. 3. So maximum is 85. Until now it is done. Now can you help me one small now? Left answer available. Right answer also available. Then you have to combine it. Then you will get the final problem answer. Right? Fine. Okay, whatever you got until now, it's okay. Let me ask one small line. See this diagram and talk. This diagram. Right? Let me ask one small. See this diagram and talk. Can you help me now? In this diagram, if you observe, how many times you done the division? How many times? Let's check. In this diagram, see this one. You divided here. Here also you divided. Here also you divided. Can you help me now? In this diagram, how many times you divided? Here one division. Here also one division. Here also one. I think 3 divisions you done. Fine. Right? In this diagram, if you do 3 divisions, compulsory 3 combines required. See, here combine. Here also combine. Here also combine. How many divisions you done? Those many combines required. Right, now can you help me? What is the meaning of combine? Using sub-problem solution, getting the right parent solution. Using children's solution, getting the parent solution. See, using these two, getting this. Using these two, getting this. Using these two, getting this one. Can you help me now? This combine is completed. You got the 90-20. This combine also completed. You got 85-3. This combine I am doing. Can you help me now? Let's combine here. Can you say combine algorithm input? I want to combine now. Can you say combine algorithm input? What is the answer? Sub-problem solutions. Combine algorithm input is going to be subproblem solutions. Can you say to this problem? To this problem. Combine algorithm input. What is the answer? Left hand side 1 maximum, 1 minimum. Right hand side 1 maximum, 1 minimum. Totally 4 values. Combine algorithm input is going to be 4 values. From the left side 1 max, 1 min. Right hand side 1 max, 1 minimum. Right? Totally 4 values. Can you say after combine algorithm is over, what is the output? Left side, right side, whoever is the maximum element. Right? Left side max, right side max, compare. Whoever is the best one, that is the maximum. Left side minimum, right side minimum, compare. Whoever is the smaller one, right, that is the final minimum. So try to remember, combine algorithm for this problem is input is going to be 4 values, output is going to be 2 values. How you got the 2 values? Out of left max, right max, who is the final max? Out of left min, right min, who is the final min, right? So like that 4 values it will take. Combine algorithm will take 4 values. It will finally return 2 values. If you want, you can check here also combine. Left 2, right 2, combine 2. Next one, left 2, right 2, combine 2. Now I will combine here also, right? Here 2 will come. Let's check here. Left 90 maximum, right 85, overall max 90. Left 20 minimum, right 3, overall minimum 3, like that. Some people are asking, whenever this process, whenever this story is going on, you are doing every time different or same recursion. What is the meaning of recursion? Right? Doing the same thing again and again. How same thing again and again? See, one divide until some point of time. What is the answer? After sub problems are solved, combine. How many times you divided? Those many times you have to do combine. Right? Fine. This is the every divide and conquer algorithm. Because of the recursive program, this kind of behavior will be there. Can you say how many parts you are dividing like this? Mid element. See this one. Mid element. Mid means when you say mid, right? When you say mid, divide by 2 parts you are dividing. If I do divide by 3 parts you are dividing. So I see this one. First element place plus last element place by 3 parts I am doing that time. By 2 means 2 parts. So binary tree came. Right? So after getting the 2 parts, left also call recursion, right also call recursion, they will do further story. Now again I am asking you, can you help me now? When you say divide and conquer, 4 major functions are there. What are those? When it is small, you know, this is the small. If it is small, what you are doing? See, small, 1 element, 0 comparison, 2 elements, 1 comparison, small, this is the story, solution, these many comparison. If it is big, how you are dividing? Like this. If it is a combine, how you are combining? So I explained to you until now. Combine algorithm input 4, output 2. Okay, some people are asking 4 values I will take, I will get the finally 2 values. How I am getting? 2 maximums you compare, 1 comparison. 2 minimums you compare, 1 comparison, 2 comparisons. Take 4 values, combine algorithm, it will give 2 by doing 2 comparison. And one more. See this one? See everyone? Whenever recursive program is executing, which data structure you are using? Stack you are using. So this is the stack. This is the stack. Can you help me one small one? This is the stack, it's okay. Who is the bottom of the stack? C1. Who is the bottom of the stack? C1, which is nothing but root of the tree. This tree root, C1. C1 will be there. Right? Bottom of the stack is going to be root will be there. Because of he is the first person. He will call their children next level. They will call their children next level. Do you believe or not? This recursive tree is equal to this stack. Both are same. This recursive tree, this stack, both are same. If you want, you can check. See this one? It is the level 1. It is the level 2. It is the level 3. Please check. Same. Level 1, level 2, level 3. See this one. This recursive tree, if we show in the form of a stack, if you just rotate with 2, right? If you just rotate with 180 degrees, right? Same thing. Both are similar. Can you help me? In this recursive tree, how many levels are there? 3 levels, right? This stack contains 3 units. 3 units only. This recursive tree contains 3 levels, right? Stack contains 3 units. Some people are asking, total functions are 7. Total function calls are 7. Stack units are only 3. Why? You are reusing the same unit again and again. See, all children will use, see this one. Sorry, all siblings will use same slot. All siblings will use same slot. See, totally 7 function call, but levels are 3 only. So, 3 units of stack is enough. I said to you in the previous classes also. Now also I am saying, can you help me now? Recursive program, careful listen. Recursive program, stack space based on what? Recursive program, stack space based on what? What is the answer? if anyone don't remember, at least now you remember. Recursive program stack space based on number of levels in the recursive tree, not number of function calls. Some people are confusing. Recursive program stack space is nothing but number of function calls. No, number of levels in the recursive tree. How many levels there? 3 levels, 3 units of stack. Some people are asking, 3 levels there, it's okay. But if you see some level, many function, in one level many function call. See this one, in the third level many function call. In the second level 2 function call. In the first level 1 function call, it's okay. Second level 2 function call. Third level is 4 function call. If 4 function calls are there in the third level, how can you say 1 unit of stack is enough? What is the reason? 4, see, in the third level 4 function calls are there, but all will not come at a time. One will come first. It is over then second. It is over then third. You can reuse it. Again I am repeating now. Recursive program stack space based on not number of function call, number of levels in the recursive tree. Please remember this. Please remember. This recursive tree, this stack, both are same. Just this recursive tree. 180 degrees you rotate. You will get this. Can you help me in this tree? How many levels there? In this tree, how many levels there? In this tree, 3 levels there. In this tree, 3 levels there. Right? 3 units. 3 levels are there. 3 units. Some people are asking, in this recursive tree, 3 levels there, 3 units of stack, it's okay. Some people are asking, sir, why 3 levels? This recursive tree contains 3 levels. So, 3 units of stack, I am okay. But why 3 levels? What is the reason? Can you help me now? What is the reason? 7 elements are there, right? 3 level tree you got. What is the reason? The reason is going to be 7 element, 3 level tree came. The reason is going to be you are dividing 7 by 2, by 2, by 2, by 2, by 2. If you always dividing by 2, by 2, by 2, by 2, log n base 2 will come. Always remember, right? The tree height is completely based on how you are dividing. If you always divide into by 2, by 2, by 2, log n base 2. If you always divide by 3, by 3, by 3, log n base 3. If you always divide minus 2, minus 2, minus 2, n by 2. If you always do minus 10, minus 10, minus 10, n by 10, please be careful. Because of always you are dividing by 2, by 2, by 2, 3 levels came, right? What is the answer? Log n base 2. Right? That is the reason log n base 2. So, 3 levels came, right? Stack size is going to be log n base 2. Log 7 base 2 is going to be same. Until now, whatever is happened, let me explain now. See this one. I took one problem. This is the problem. This is the array. I took one array, right? I think to this entire one. Finally, what is the maximum? From the left group maximum is 90. From the right group maximum is 85. Overall max is 90. From the left group minimum is 20. From the right group minimum is 3. Overall minimum is 3. So let's see this one. Listen, those people who confuse a little bit also, I want to say one small thing. Please listen. Small confusion also there. You listen this. You will get the clarity. Can you help me now? What is the story going on? Finding maximum minimum in the given array. Finding maximum minimum in the given array using divide and conquer. How? That is the story. Finding maximum minimum in the given array using divide and conquer. How? That is the story what we are discussing now. Right? To that what I done is to that. So I took one array. Right? Now I asked, I think when you say divide and conquer, some terminology will come. What is the terminology? When the problem is small, like this. 1 element or 2 elements. Next one. If the problem is big, how will you divide? Like this. Mid element find out, divide. Right? That's fine now. So I done the similar story for this example. See this one? This example I took. So array A which contain 1 to 7, finding maximum minimum. Big divide by taking mid element. If fractions will come 2.5, take 2 only because mid is an integer. Again, here also big problem divide. Here also big problem divide. Like that I done. Next one. After completion of the diagram, because of so many there, I don't know who will be called first and all. I explained that also. He called first. Everyone know main program will call first. He will call, see this one, in the entire program who called first? Main. Main called first doesn't mean that main will complete first. Main call, but he have to wait because main is based on inside. Some people are there. Inside people of main over, then main over. To complete main, their two children are required, these two. First left required. To complete this one, their two children are required, like that. So E will call, right? But E will complete first. So function calling order I given, function execution order also given. Function execution order is post order, calling is pre-order. Next one. Whatever is happening here, push and pop. Can you help me? Who called first to C1? When you say C1 is called first to push. Next one, C1 is called first, push. Next one, C1 will call whom? This one. C2 also push. C2 will call whom? C3 also push. But C3 don't call anyone, pop. It is popped means you will go next to. C4 will call. Because of sibling, all siblings will be in the same level, C4. C4 also don't call anyone, completed. Then because of both the children over, parent over. Then parent over means cancel parent. Like that continue until total tree over. Now I want to say one thing to you. Please listen. This tree is equal to this stack. The only thing is different way of representation. Right? In the tree, root will be first. Afterward, their children. Leaf nodes will be last place in the tree. But in the case of the stack, what will happen? Right? I think root will be at the bottom. Children's will be there at the top. Leaf nodes the top in the stack. Right? In the tree, leaf nodes will be at the bottom. This diagram is equal to this one, which is equal to array. On array, I done. See this one. I think it is the first one. Right? It is the first one. Afterward this. Then this is over. This is the first one in this side. Afterward this one. This is done. Lastly combine. All three will be similar. If you know one part also, it's okay. Can you help me now? When our recursive program is running inside the computer, which data structure you are using? Stack. In that stack, how they are growing and how they are shrinking, like this. C1 push, C2 push, afterward C3 over, then C4 will push, like that. Right? Whenever recursive program is going on, right, inside the computer system, so many functions will be pushed and popped also, like this. Same tree, right? Keep in the form of stack, like that. These two things, right? This is also okay. I'm thinking that you got a little bit idea. Let me ask you, in this diagram, how many times you done the combine? How many times you done the divide? Those many times combine. When the problem is small, this is story. How will you divide? This is the story. How will you combine? You know. Can you say how will you combine? Combine algorithm input, 4 values, output, 2 values. How? By doing 2 comparisons. Left and right maximum compare. 1 element will come, right? Left and right minimum compare, 1 element will come, right? Like that. I'm thinking that this numerical example, whatever I explained to you, you are a little bit okay. After writing algorithm, you will get more clarity. And before going to that, just I want to ask you one small line. Recursive program stack space based on number of function call or number of levels? Number of levels. Can you say what are the number of levels in this problem? Log n. Why? While dividing, always I am dividing by 2, log n. Log n level stack k. 3, how 3? Log n level. Always by 2 you are doing, log n level. Log n level stack required because of always by 2. If you do always by 3, log n base 3 levels. I'm thinking you are a little bit okay. Let's go to the program. So I'm writing the program here itself. See this one, I'm starting. Small doubt also there. Please take care about this program. Listen, one more thing I want to say to you. As a computer science student, listen, carefully listen. As a computer science student, I may say big story, you no need to believe. You may say big story, I may not believe, right? So as a computer science student, at the end of the day, you should write program. Program, if you are okay. So some students are thinking that, some students are indirectly, they want to say one thing. Sir, whatever you said until now, we are okay, but we are not that much confident, right? You are not that much confident until now. Reason is, program I didn't written. CSE people, every CSE person will say that, you just write the program, then we'll see. You got until now, little bit also it's okay, because program I am not written. Now I will write program. Some people are thinking that recursive program, right? Some people are thinking that to this entire story, if you write the program may be very large and all. No, program is very small. Why? Recursive program. Recursive program contain only 2 parts, if part, else part. Just I think if you remember the control abstraction of divide and conquer, same algorithm I will write. Can you help me now? Control abstraction of divide and conquer algorithm, whatever we done previously, same algorithm I will write. But what is the difference? The algorithm which I am going to write here, The control abstraction divide and conquer algorithm. What is the difference between both the algorithm? In that algorithm, few gaps there. But in this algorithm, those gaps I will fill. Other than this, nothing there. So, as a CSE person, you may not be comfortable until now. Now you will be comfortable because I am writing the program. And one more thing, program is not that much big also because it is a recursive program. And one more, this program you know also because control abstraction and this program same. In that few gaps are there, now no gaps will be there. I am starting now. Until now I explained numerical example only. Now I am writing the program. Let's see the program. Can you say, what is the program name? See this one, program name. Divide and conquer max min. Program name is divide and conquer max min. Can you say input? Program name is divide and conquer max min. Can you say input? Array A which contain necessary things on I am writing. Divide and conquer max min is the program name. Input is going to be array A which contain I to j element. What is the I? First element position. What is the j? Last element position. This is the function name. Our program name is this. Right? Can you help me now? Array A which contain I to j element. Using divide and conquer, I want to find out a maximum, minimum. Can you say first step? Can you say first step? Using divide and conquer, I want to find out a maximum, minimum. Right? Array A which contain I to j. Can you say first step? As soon as you enter inside the algorithm, first step, when the problem is small, you know very well. When the problem is small, one element or two element. I am writing now. See this one? I am writing. If what is the I? First element position. What is the j? Last element position. See what I am doing. If I is equal to j, what is the meaning? If I is equal to j, what is the meaning? One element is there. Starting position is equal to ending position. It means one element is there. If one element is there, please remember. If one element is there, maximum is equal to minimum is equal to that itself. Only one element is there. Everything is that itself. If first element position is equal to last element position, what is the meaning? Starting element position, ending element position, both are same means only one element is there. If one element is there, maximum is equal to minimum is equal to that itself. This one everyone know. One element is there, small problem. See, one element is there, small problem. Then solution is this one. This is the solution. This is the solution. And one more. See the next one. Suppose this is fail. What is the meaning? When one element case fail, then what is the meaning? If one element case fail, the meaning is going to be, right? The meaning one element case is fail mean that is the reason I came to the else part. See the answer. As soon as you came to the else part, see this line also. See this line. If I is equal to first element position is equal to last element position minus 1. If I is equal to j minus 1. Can you help in I value 1, j value 2? What is the meaning? Two elements are there. I is equal to means 1 is equal to j means 2. 2 minus 1 is 1. 1 is equal to 1. This indication that one element fail means I came here. Two elements pass. Yes, this indicates two elements. I is equal to j minus 1. What is the meaning? J is greater by 1. Compare I is the first element position, j is the second element position. Right? So I is equal to 1 is equal to 2 minus 1. This indication that two elements. If two elements are there, then also small problem. Then what is the solution? If two elements are there, then also small problem. What is the solution? This is the solution. See? Then solution is going to be, let me check here. If AI is less than AJ, if AI is less than AJ, then who is the maximum? Then maximum is equal to AJ, min is equal to AI. Else maximum is equal to AI, minimum is equal to AJ. So, if two elements are there, this is the story. If one element is there, this is the story. If one element, this is the story. If two element, this is the story. Let me write little bit better way. See this. This indication that one element. This entire story indicates two elements. This indicates two elements. And one more. One element, do this. Two element, do this. Next one. This entire story is called as small problem. This is called small problem. Small problem and solution. If one element, this is the solution. If two element, then this is the solution. And else also there. What is the meaning? One is pass, then don't go to 2. One fail, then go to 2. 2 pass, then this is the story. So can you help me one small line now? See this one. What is this area? Small and solution. If small, this is the solution. If small, then this is the solution. This is called small and solution. Can you help me now? In the last class also same algorithm I written. Now also I written same algorithm, but what is the difference? In the last one, right, small also I kept gap, solution also I kept gap. Now I filled the gap. What is the reason? Yesterday whatever I written, in the last class whatever I written, that is the abstract algorithm. What is the meaning? That is not belongs to any problem. Now this is belongs to find max min. Because of specific problem, I can write the code. If the problem is, I don't know the problem, then what purpose I will write the code? So, in the last class, we done the control abstraction of the divide and conquer, indication that we are hiding something. We are saying the meaning, but we are hiding. We are not explaining when the small and all. Now I am saying clearly when the small. What is the solution? This algorithm and the last class algorithm same. There gaps there, here no gaps are there. Directly code I written. This is called a small problem and solution. Let's go to the next one, right? Suppose, right, this is the if and else, right? This is true, then this is. Suppose this is fail, then this is. Supposition that if this is true, right, internal story. Supposing that this also fail. Major story coming, listen. This also fail. This fail, then come here. This also fail, then I came here. See, I came here. Just let's see this one. I came here. If you want, I will write the, I think I want to write in this area. Anyhow, fine. So I am writing in this area. See this one. If this if is fail, let's come to the major area. Because of the major area, I am writing else part. Can you help me now? What is the meaning of this else part? This else part you came indication what? Can you help me now? Right? This else part you came. What is the indication? One fail, then you came here. This is fail. That is the reason I am coming here. This is fail means what is the meaning? Two also fail. One fail, two fail. Indication that, right? More than two. Indication that problem is a big problem. This is the area where divide and conquer will start. More than means problem is a big problem. Come to this else part. Now I am starting. Can you help me now? Assume that I is 1, J 7, right? Can you help me now? Problem is a big problem. What will you do? Simple. Just find out mid is equal to. Problem is a big means what? You have to divide. Mid is equal to I plus J by 2. Just find it and do this. Some people are asking, mid is equal to I plus J, because the problem is a big, divide. Divide into two parts. Yes, I done. Some people are asking, sir, I got fractions. Then 2.5. What should I do? Should I take 3 or 2.5? 2. Because of mid is an integer. In the programming, I will write int mid. Right? Because of it is an algorithm. Right? I am writing the something like this. Fractions will come, take smaller one. Next one. I done the division. Can you help me now? As soon as you enter into the else part, I have to divide. This is the divide code. Can you help me? In the last class also, I written same. But what is the difference? In the last class I written divide function I written. If I go there, code not there. In the yesterday's class I said to you, divide means you will divide. Divide means you will divide. But how you divided I didn't explain. Now I explained. Like this you have to divide. Right? In the abstract algorithm, gaps are there. How to divide I didn't explain. But divide means divide. Now I written the code. Like this you divide. Mid element find out. Can you help me now? 1 plus 7, 8 by 2. What is the answer? This is 4. 4k. Now what will you do? See the interesting answer. Using divide and conquer. See this one. Using divide and conquer max min algorithm. Just call the recursion on the left side. What is the array A which contain I to mid. Left hand side. I think your array. This is the array. See this one. This is your array. Because the problem is a big problem. Divide. Yes, I divided. So using recursion, left complete. You only say, this function is over. What does the meaning? You only say this function over. What does the meaning? This function over means, right, array A which contain I to J, you computed maximum minimum. If this function is over, you got maximum minimum. Indication that, right, in the total array you got maximum minimum. This function over, in the total array you got maximum minimum. If you believe this is right? Similarly, this function over means in the left side you got one maximum, one minimum. Let me write now. Maximum, minimum you got. Max 1, min 1. You got one maximum, one minimum. Left hand side maximum, minimum you got. Main function is over. If you get in the overall array maximum, minimum. If that is true, right, same function call on the left half if you do. From the left side, one maximum, one minimum you will get. Using recursion, do the same thing right also. What is the answer? Using divide and conquer max min. Using divide and conquer max mean right side. What is the meaning? A mid plus 1 to j. Right side also find maximum minimum. Using recursion do that. Yes, using recursion if you do right also, you got one more maximum, one more minimum. Max to min to. Some people are asking, sir, from the right hand side, how you get two values? You only say, this function over means, in the total array, you will get one maximum, one minimum. Total array, if you apply this function, you got one maximum, one minimum, if it is true, right? Left half, if you apply this function, left half, one maximum, one minimum will come. If anyone says, sir, it is not possible at all, here also not possible. If it is true, this is also true. Overall array, maximum, minimum coming. In the half array also, maximum, minimum will come. In this half array also, maximum, minimum came. Can you help me now? This is, recursion is nothing but conquer step. This is divide. This is conquer. Can you help me now? When you say conquer is over, how many values are with you? If conquer step is over, means subproblem solutions you got. How many values you have? 4 values. Left side 1 max, 1 minimum. Right side 1 maximum, 1 minimum. Totally 4 values came. Now you have to combine. So that final answer you will get. Right? Let me combine. I am combining. Can I say combine algorithm input? 4 values. Left side max min, right side max min. Left side max min, who are those? Max 1, min 1. Right hand side, who are those? Max 2, min 2. Totally 4 values. Let's take 4 values. Yes. Now let me do combine. I am doing combine. See this one. If everyone listen now. If max 1 is less than max 2. If max 1 is less than max 2, what does it mean? Comparing left side and right side maximum is more. Then what is the answer? Max is equal to max 2. Right only big, right only maximum. Else, what is the meaning? If this is fail, then max is equal to max 1. Next one, in the similar way, min also. If min 1 is less than min 2, then min is equal to, who is a small? Min 1 is less than min 2. Then who is small? Min 1. Min is min 1. Else, min is min 2. Right, like that. Now see this one. See, I think, can you help me know? What is the name of this code? This code, what is the name? Combine. Can you say in the abstract algorithm, what I written here? Combine. I written simply combine, but if I go to the combine, I kept gap. Now gap is not there, code is there. Right? So yesterday's algorithm, this algorithm same. Here I written the yesterday combine. Now I written the combine code. Yesterday here I written divide. I written the divide code. Yesterday I written here. So right, small and solution. I written the function name, but I written the code. This is the only difference. Right? Can you help me know which is the major part of this program? Else part only. Else part only. See, I think else part is completed here. Right. This is the if part. This one is the if part. This one is the else part. Now this is going to be end of the program. Let me write here. So see this one. If the first one is true, 1 max, 1 minimum came. If the first one is fail, second one is true, 1 max, 1 minimum came. If second also fail, right, 1 max, 1 minimum came. So anyone, either first one or second one or third one, right, anyone will give maximum, minimum. Lastly, return that. Return max, min. Whoever will give, right, see, maybe he will give. Maybe he will give, maybe this, right? One of the person will give, end of the total program. See, this is the closing for this, right? For this one, it is the closing. To this, it is the closing, right? So, suppose assume that E is given maximum, minimum. If it is true, it will fail, then you will come here. Suppose first one fail, second one pass. He will, I think maximum, minimum come here. After this is true, then it is not true, I will come here. Suppose these two fail, then here one maximum, minimum I will get, finally maximum, minimum. One of the person will give that. This is the divide and conquer max min algorithm. So can you help me in this algorithm, which is the major part? Else part. This else part. This else part. So this is the C. And one more thing I want to ask you. In this entire program, which one is taking very less time? Small problem solution, because very less elements are there. See this one. Here no for loop, nothing there. Constant time. See this one, in this program, powerful part is going to be else only. Recursive program, powerful is else only, not the if. This will take constant time, everyone know. This will take more time because here some story there. So I will do that also. See this, I will do that also. Now, I think before going further, I want to ask you one small line. Please see this. Please see. Can you help me in this program? In this program, you only say. What is the name of this? What is the name of this one? Divide. This is going to be divide. It is the divide function. It is the divide code. Can you help me? What about these two? Conquer. This is the conquer code. Right? This is called combine code. Right, in the last class, right, these all are gaps are there. Now code is there. This is the only difference. This is the combine code. Divide code, conquer code, combine code. Right, please be careful. That is a small end solution. I written already. That is a small end solution. Right, one element also small, two elements also small. Otherwise big. This is a major. In the big story, right, divide, conquer, combine. Fine, I am thinking that you are really comfortable. Can you say, are you done 2 parts or 3 parts? 2 parts. If you want 3, by 3. When you say here by 3, then here divide and conquer maximum 3 times will come. If at all 3 times, every time 2 values will come. 3 times means 6 values will come. Then here max 1, max 2, max 3. 3 people you have to compare. Min 1, min 2, min 3, then 3 people you have to compare. If you do 3 parts, 3 function calls will come. Every one will give 2 values, totally 6 values. 3 maximum, 3 minimum. 3 maximums you have to compare. 3 minimums you have to compare. So like that. This is the divide and conquer algorithm to find out maximum minimum. Right? See the next story. Right? Let's complete that also. With this everything will be over. Let's complete that also. See this? See everyone? Can you help me? What will be the further story you are thinking? So program you written. Can you help me? Until now what I done? Let's see here. Using divide and conquer, finding maximum minimum, right? What is the first step? Just I explain one numerical example. How to find out maximum minimum, right? Using divide and conquer, finding maximum minimum, right? Using one numerical example I done. Right? After that, whatever I done in that numerical example, I written in the form of a program. After this program is over, next step is going to be, you have to analyze this program. What is the meaning? Analyzing means what? This will take how much time? This will take how much space? We have to analyze. Now I am analyzing the time. Let's see here. Let's see, carefully listen. I am starting. See everyone now. See everyone. I am analyzing, very simple also. Let Tn is equal to time complexity of, let Tn is equal to time complexity of, let me write, time complexity of DAC max min algorithm, DAC max min algorithm on n elements. That may be I2J means n elements are there, right? Don't worry. See this one, let T of n is equal to time complexity of DAC max min algorithm on n elements. That n you may give whatever way you want. N may be directly give n, right? I to j also give which contain n elements. Tn is equal to time complexity of divide and conquer max min algorithm on n elements, right? Assume. That is the meaning of Tn, right? I am writing. Can you help me now? In the last class I explained this also. Please help me how to find out recursive program time complexity. In the last class I explained how to find out recursive program time complexity. How to find out? If you want to find out recursive program time complexity, write the reconciliation and solve it. Write the reconciliation for time. That is the reason I written. See, let Tn is equal to time complexity. This recursive program time complexity, if I want to find out, I should write the reconciliation for time. So I written Tn is equal to time complexity. Right? Otherwise I will write here. You see this one. Reconciliation for time I have to write. I am writing. Reconciliation for time I have to write. I am writing. See, Tn is equal to time complexity of DAC max min algorithm on n element, right? So if you are okay, let me write Tn is equal to, don't confuse, Tn is equal to, let's go there one by one. Tn is equal to, see the answer, time complexity of this algorithm on n elements, Tn is equal to, what is the meaning? This will take Tn, this is taking Tn, This algorithm on n, assume that n elements here. This will take on n elements Tn time. That is okay. Can you help? You only say this algorithm on n elements will take Tn if you believe that that is right. This algorithm on n elements will take Tn time if you believe that is right. Can you help me now? DAC algorithm on half array, how much time? Tn by 2. Same DAC algorithm on half array, what is the answer? Tn by 2. Total function call will take Tn time. Definitely half function call will take Tn by 2. This is also Tn by 2. That is the conquer time. Everyone know, right? Now come here now. Can you say what about small problem? See this one. One element is there. How much time? No loop. Constant. Two elements are there. Is there any loop? No. Constant. Right? Let me write the same. One element. No loop is there. Time complexity means loops only. Recursion is recursion. You know very well. Recursion is recursion, that is okay, but remaining things are normal. Loop is there, then only time. So one element, no loop, constant. Two elements, no loop, constant. Right? Come here now. I am writing. Time complexity of this algorithm on n elements, Tn is equal to, what is the answer? See the answer? Constant time if n is equal to 1. Next one, constant time. If you want, I can combine also. Constant time if n is equal to 1 or n is equal to 2. N is equal to 2. So n is equal to 1 or n is equal to means one element or two element constant time. That's fine. Can you help me now? One element or two element constant time, that's okay, right? So small problem, this is the story. See the big problem. If the big problem means else part. Can you say what is the conquer time? Tn by 2, Tn by 2. Conquer time, it's okay. Can you help me now? What is the divide time? Before conquer, there is a divide. Can you help me now? What is the divide time? Because of, see this one, divide. See the code also divide. Divide code. If you see the divide code, is there any loop in the divide code? No loop. If no loop, constant time. Time complexity means loops only. Is there any loop here? No. Constant time. So divide time, constant. What is the conquer? Recursion is recursion. 2Tn by 2. Next one, combine. This is the combine code. Can you see in the combine code, is there any loop? No loop. No loop means constant. Please be careful. No loop, constant. If n is greater than 2, this is the story. Time complexity of this program, DAC max min, Tn is equal to small problem, constant. If the big problem, divide, no loop, constant. Conquer, 2Tn by 2. Combine also, no loop, constant. Now let's simplify. I am simplifying now. Tn is equal to 2Tn by 2. Constant plus constant, constant. Right? This is the recurrence relation. This is the, can you help me now? This is the recurrence relation for a divide and conquer max min for time complexity. If you solve this one, you will get time. How to find out recursive program time complexity? Write recurrence relation for time. Yes, I written. See, recurrence relation for a time, right? So when you say time, loops only. Divide, no loop, constant. Conquer is conquer, same. Combine, no loop, constant. So 2Tn by 2 plus constant, simply C. C is a constant. Right? Fine. Now some people are asking, sir, how to solve this one? Right? You can go for substitution method, you can go for recursive tree method, you can go for master theorem, do whatever way you like. Everything is okay. If you go to the master theorem, directly answer will come. If you go to the substitution method, it may give stepwise answer. Can you help me one small line? What is this C? This C is going to be amount of time required for both divide and combine. Divide is constant, combine also constant, overall is constant. This is the amount of time required for both divide and combine. It is a two sub-problem, each of size n by 2. See this one, two sub-problem, each of size n by 2. Next one, divide time is constant, combine time is constant, overall C. What is this C? Amount of time required for both divide and combine. Two sub-problem, each of size n by 2. Right? Fine. I am thinking you are okay now. See this. See everyone. Let me solve this. Let me solve. Using substitution method. Anything is okay. I am doing substitution method. See the substitution method. 2e in the place of 2, same. Right? 2t n by 2 by 2. N by 2 square plus n there C. N by 2 also C. Outside C is there. Let's simplify. 2 square t n by 2 square plus 2c outside C there. I think 2 rounds over this is the answer. Let's do third time. 2 square, 2 square. This is going to be 2t n by 2 square by 2, 2 cube plus C outside 2c there, 1c also there. If you simplify, 2 cube tn by 2 cube plus 2 square c plus 2 power 1c, 2 power 0c. You know very well, 3 rounds over, this is the story. Right? 3 rounds over, this is the story, it's okay. Right? So let's do k rounds. Then it will become 2 power k t n by 2 power k. You know substitution method very well. C common. Let me write in the reverse order. See, it is the 3 means it is the 2. It is the k means I think it is the k minus 1. Let me write in the reverse order. 2 power 0, 2 power 1, 2 square and so on. Lastly, 2 power k minus 1. Next one. What is the next one? This n by 2 power k. Right? Let me write now. This n by 2 power k, I am writing, I'll see. N by 2 power k is equal to. So this should be termination condition. N by 2 power k is equal to. You only say, how many terminations are there? 1 also termination, 2 also. N is equal to 1 also, you can stop. N is equal to 2 also, you can stop. Anything is okay. But who will come first? Assume that take one big number, you divide by 2, by 2, by 2, by 2. Right? Who will come first? 1 will come first or 2 will come first? 2 will come first. Is if anyone having doubt, take big number 16. 16 by 2, 8. 8 by 2, 4. 4 by 2, 2. 2 will come. If 2 missed out, 1 will come. So I think 2 will come first. So you can stop at 1 also, 2 also. I am stopping at 2. Anything is okay. N by 2 power k is equal to 2. N is equal to 2 power k plus 1. Log n base 2 is equal to k plus 1. K is equal to log n base 2 minus 1. Because of you are stopping one step before, minus 1 will come. If you go until 1, log n. If you go until 2, log n minus 1. Replace k is equal to, let me replace. Log n base 2 minus 1. I am replacing. You know substitution method very well. Log n base 2 minus 1. It is a 2. C. 2 power 0, 2 power 1 and so on. What is the last one? K. K means log n minus 1. K minus 1. Log n base 2 minus 2. Right? So what is the 2 power log n base 2 minus 1 means? 2 power log n base 2 by 2. T of 2 is constant. Plus C into this GP series you solve. 2 power 0 to 2 power log n base 2 minus 2 means log n minus 1 terms are there. A into means 1. R power 2 power log n base 2 minus 1 by R minus 1, 2 minus 1. Right? Forget about small thing, big function. What is the 2 power log n means? N by 2 into constant plus C into here also bigger one is 2 power log n base 2 which will goes to n by 2 into constant, it's okay, right, plus C into it is also n. Overall observation is, right, theta of n, left side, right side, bigger function same, n is the answer. So if you solve this reconciliation, right, if we solve this reconciliation, I got final answer as n. What is the meaning? This program time complexity, whatever program we written until now, this program time complexity theta of n. Let me write time complexity of this program theta of n, which case? Every case using divide and conquer, finding maximum minimum like this, no other change, right? Using divide and conquer to find out maximum minimum. This is the procedure what you have to follow. You cannot eliminate anything. Divide, conquer, combine. Every time same story you should do. So time complexity theta of n, every case. Right? Every case time complexity theta of n. It is the reconciliation for time complexity. If you solve using substitution method, right, final answer is n. If you solve substitution method, final answer is n. Now how many people will give? Right? One interesting thing I want to say to you, please listen. Whenever you are finding maximum minimum using divide and conquer, you only say, whenever you are finding maximum minimum in the array, right, in the array of n elements, I am repeating once again, when you are finding maximum minimum in the array of n elements using divide and conquer, you only say, you are always dividing by 2 by 2 by 2 or not? Yes. Then how many level tree will come? Log n level tree will come. Log n level tree will come, right? You are dividing many times, divide by 2 by 2 by 2, log n times you are dividing. Please be careful. right? But one thing, how many times you divided, those many times you have to combine also. Everywhere you are dividing, combining, dividing, combining. Can you help me now, right? Log n levels you are dividing, log n levels you have to combine also. Log n level 3 will be there. Everywhere you have to divide, combine. Can you say what is the divide time, combine time? Divide time constant, combine time is constant. What is the meaning? Everywhere divide time, combine time is constant. If you want, you can check log n level 3 there. Every level divide time, combine time is constant. See this one? See the interesting answer, right? It may be trouble you, you have to listen properly. See this one. N elements are there. N elements are there. First divide. N by 2, N by 2, 2 parts you done. If you divide constant, you have to combine back also constant, right? Overall C time. Divide time, combine time. Divide time, constant. Combine time, constant. Overall C. Same story will repeat further also. What is the meaning? Here also. Divide time, constant. Combine time is constant. Next one, here also. Divide time is constant. Combine time also constant. Right? Overall observation if you observe. See this one. Divide time, combine time. Constant plus constant, which will goes to constant. Here also. Divide time is constant, combine time also constant. Constant. Overall is 2C. Right? Next one. Here also same. Divide time constant, combine time constant. 1C. Divide time constant, combine time constant. 1C. Like that it is keep on going. So how many C's will come? 2 square C. That's what going on here. See. Whenever substitution method is going on, see, divide time, combine time. It may be trouble you have to listen this. See this one. This is the divide time, combine time. Next one, it is the divide time, combine time. Next one, it is the divide time, combine time. Some people are asking, divide time, combine time, why are you writing many times? This is the divide time, combine time, first level of the tree. This is the divide time, combine time, second level of the tree, because second level 2 children are there, first level only 1. Second level 2 children. This is the divide time, combine time, third level, right? Like every level divide time, combine time. Whenever divide and conquer you are using to find out maximum, minimum, log in level 3 came, every level you are dividing, combining. So every level cost required. First level cost C, second level cost is 2C. Why? I think 2 function call. One function call is taking C time. Right, second level 2 function calls are there. Those 2 will produce 2 more, right? I think 4 function call. So every function call cost, dividing, combining, constant time. So like that one series going on, same series. So in one of the class, one student asked me, whenever substitution method is going on, every level one non-recursive term is coming. What is that non-recursive term? What is the non-recursive term? In that level, divide time, combine time. Substitution method is going on, every level one non-recursive time is coming. What is that? What is that? Right? In that level, some work you done, that work cost. Right? In that level, divide time, combine time, how much that will give. If we add all of them, total cost will come. Right? This will goes to total cost. See, first level divide time, combine time. Second level divide time, combine time. Like that, how many times you done? Divide by 2, by 2, by 2, by 2, by 2 until 2 will come. Right? Log n minus 1. If at all, if you go until 1, that is also okay. Log n minus 1 plus 1, don't bother. You are keep on dividing until log n time approximately. So every level divide time, combine time. Please remember, whenever substitution method is going on, every level one non-recursive time is coming. That is the divide time, combine time. At that level, every level you are doing. You are not doing one time, right? You are doing many times, right? That is the reason one series came. This is every level divide time, combine time. Right? Please be careful. Some people are asking, every level divide time, combine time, if I add all of them, total cost will come, it's okay. But what about this? What about this? Try to remember, this is the divide time, combine time, every level, that's fine. This is last level. This is going to be last level. Last level, can you say, in the recursive tree, who are there in the last level? Last level is small problems, right? N by 2 small problems are there. Each of size 2, each of size 2. N by 2 N by 2 small problems are at the bottom of the tree, leave, right? So 2 elements are there, small problem, 2 elements are there, small problem, cost is constant. So this is the last level cost, this is remaining all level cost. Every level, it is a big problem, it is a small problem. Small problem cost also you have to add, small problem cost plus big problem cost. Where is the small problem? In the tree, last level. Last level cost, before level cost, right? Before last level, it is a big problem story, it is a small problem story. If you combine all, total cost came. This is the small problem cost. It is the big problem cost, which is nothing but in the recursive tree, right? Leaves cost. This is the non-leaves cost. If you add total tree cost will come. Total tree cost. Some people are asking, sir, why n by 2 came? You only say 2 elements is a small problem, you are stopping. See this one. Everywhere 2 elements are there. 2. If at all n by 2 times are there. Total is n elements. Everywhere 2 elements. Like that n by 2 times. N by 2 into 2, totally n elements. So n by 2 leaf nodes are there, each of size 2. 2 element solving is a constant, n by 2 constant, right? This is the small problem story, this is the big problem story. If we add total cost will come, right? So try to remember, it is a small problem, it is a big problem, total is this, right? So now listen, after writing the recursive program, what is the next step? Analyze the recursive program. How? Just time complexity purpose, write the recurrence relation, solve it. So while solving, which method I used? Substitution method. Can you help me now? To this recurrence relation, if I use substitution method, if I use the master theorem, who will give correct answer? Both will give correct answer. But what is the advantage with the substitution method? It will say every level what is going on. What the master theorem will give? It will give directly final answer. Master theorem will give directly final answer. Substitution method also finally will give answer, it's okay. But it will say every level what is going on. Every level something is adding. What is that? In that level, divide time, combine time. Can you say final answer what is came? Theta of n, that is the time complexity every case. Why time complexity is theta of n every case? What is the reason? Every time you have to divide, conquer, combine. Because of every time you have to do divide and conquer and combine, same answer will come. Right? And one more. See this line also, one small thing pending. This is the time complexity. See the space? See the space also, careful. See the space complexity. Space complexity is going to be input plus extra. Space complexity is going to be input plus extra. Can you say what is the input? Because of array of n elements, what is the answer? N bytes. Can you say what is the extra? Everyone know. It is a recursive program or non-recursive program? It is a recursive program or non-recursive program? Recursive program. Recursive program is stack required or not? Yes. Can you say it is a recursive program, stack required? Can you say what is the size of the stack? Try to remember, size of the stack is based on, right? This is the answer. Size of the stack based on k. What is this k? How many times you are substituting? You are substituting log n time. That is the advantage with the substitution method. He will give every level of what is going on. He will give how many times you done also. In the recursive tree, log n levels are there. K times I repeated, where k is log n, right? That is the stack size. Please be careful. Recursive program, stack space is based on number of levels. Not in every level how many? Number of levels, right? I think extra space is going to be what the answer? Number of levels. Let me write. Number of levels. Which is nothing but a k value. What is the k? Approximately log n bytes. Extra is going to be log n bytes. Input is going to be n bytes. Overall is n bytes. People will ask extra only. Because everyone input is same, right? So extra is going to be log n, input is going to be n bytes, overall is n. Right? Please be careful. Right, and let me ask you one small straight max min, what is the extra space? Straight max min, what is the extra space? Because of recursion is not there, 1 unit of stack, one function call, 1 unit. So straight max min, what is the stack space? Because of it is a non-recursive program, right? One call only there, 1 unit of space. But here it is a recursive program. Log n level stack required. So log n space. Extra only. See this one. When you say space complexity finding, input plus extra, it's okay. But when you are comparing two algorithm, no need to write input. Just to take the extra only. Extras compare. I think previous algorithm extra how much? 1. This algorithm extra space n. Which is better for the space? Previous one. Can you say previous one time complexity? If you want, you can remember. Previous one time complexity. What is the answer? One for loop is there. N. It is also n. Time complexity point of view, both are same. N. But here extra space is going to be log n. But straight max min is 1. Straight max min is order of 1 space extra. Here log n. Every algorithm having its own drawbacks and all. Right? But our goal is this one. Our goal is finding max min using divide and conquer. Our goal is finding max min using divide and conquer. I done that also. Total story one time you study, that is enough. Right? Previous one already there in your notes, this one. Finding max min using divide and conquer. How? What is the answer? First I explained numerical example. Because of your okay, I written the program. This is the program I written. This program and yesterday's program same. The only thing is gaps are filled. After program is over, recursive program. How to find time? Write the recurrence relation for time and solve it. While solving, what is the k came? That is stack space. Next one, while solving, every level some non-recursive time is coming. What does it mean? That level cost. So, if we add all these things, right, big problem cost will come. Lastly, something will come left side. That is going to be small problem cost. Total, if you add, total cost will come. Master theorem also you can do. He will give final answer. He may not give anything else. But substitution method will give how many level tree came, every level, what is the cost and all. I'm thinking you are okay, right? If anyone not okay, please revise the entire thing one time. Right? Fine. Next one small thing is there. Let me do that also. Listen, that is also really required. Let me do that also. This recursive program is given. You only say, this recursive program is given. To this recursive program, I want to find out number of comparisons between the elements. How? To this recursive program, I want to find out number of comparisons between the elements. How to find out? Can you help me now? How? To this recursive program, how you find out time complexity? Write recurrence relation for time. Then you will get time complexity. To this recursive program, how many comparisons are there? How to find out? Write the recurrence relation for comparisons. Then you will get a comparison. What you want, for that, write the recurrence relation. You have to concentrate properly. Otherwise, you may do mistake. You want to this recursive program, you want comparisons between the element? Yes. Then concentrate comparisons only. Remaining things don't concentrate. To this recursive program, number of comparisons between the elements, how many? I want. Just let's see how it is. How to write recurrence relation for number of comparison. Recurrence relation for time complexity you done. Recurrence relation for comparisons I am doing. First time I am doing. Right? It may trouble you little bit, even though it is troubling, there is no problem. First time is like that only. Try your level best. I am writing. See this? To this recursive program. I am writing here. See this. Right? See this one. To this recursive program, let me, I am clearly I am writing. See this one. Clearly I am writing. See this one. Recurrence relation. Recurrence relation for comparisons. Recurrence relation for comparison. Let me write. For comparisons. Between elements. Recurrence relation for comparisons between the elements. How it is, I am explaining now. Very simple, see this. I am explaining, see this one. Tn is equal to comparisons for DAC max min of n elements. DAC max min algorithm on n element, number of comparisons are going to be Tn assume. Previously this is the time, now comparison is equal to. Comparisons only count, please be careful. When you say time complexity, loops. But here comparisons, count only comparisons. Some people are asking, sir, how? I am doing. See this one? Tn is equal to comparisons between the elements. Please be careful. Between the elements. How it will be done? I am starting. See this one? Very simple. Go there here. Small problem. Can you help me now? Small problem. You only say one element. How many comparisons to find max minimum? One element. To find maximum minimum, how many comparison between them? Only one element there with whom I will compare. No one there. So, T of n, number of comparisons is equal to 0 comparison if n is equal to 1. And one more thing, because of you want comparison, don't write more, don't write less. As it is, you write. One element is there, how many comparison? 0. Don't write more, don't write less. But if anyone write order of 1 lakh compare, order of 1 means constant. It may be 1 lakh also, no. Time complexity you can write like that. When you say comparison, as it is, you write. Number of comparisons, Tn is equal to 0 if n is equal to 1. Can you help me now? If n is equal to 2 elements, how many comparison? 1 comparison. Let me write that also. one comparison if n is equal to 2. Two elements, one comparison. Comparisons only count. One element, zero comparison. Two elements, one comparison. Now come here now. Now come here. Major portion is coming, come here now. Please help me now. When you come to the else part, what is the meaning? When you come to the else part indication, there are more than two elements. When you come to the else part indication, there are more than two elements. You only say, right? This total algorithm on n elements is Tn comparisons. Total algorithm on n element Tn comparison. Can you help me now? Half algorithm on n by 2. How many? Tn by 2 comparison. Recursion is always same. Tn by 2. But one thing I want to ask you. Conquer is always same. 2Tn by 2, that is okay. Divide, conquer, combine. Can you say divide purpose? Divide purpose. How many comparison? Is there any comparison here? No. 0. No comparison. Please check. When you are dividing, you are dividing. Where is the comparison here? No. Next one, conquer 2Tn by 2. That is okay. Can you say when you are combining, right? In this combining, right? Any comparison? Yes, 1 here. This is the meaning of comparison. This is also 2. Right? Combining is 2 comparison. Divide, no comparison. Conquer, as usual, 2Tn by 2. Combine, 2. So let me write all. Divide, 0 comparison. Conquer, 2Tn by 2. Don't write more, don't write less. Combine, 2. If n is greater than 2. This is for comparison. Number of comparisons for DAC of max min is number of comparison for DAC of max min of n is Tn. So DAC max min of, right, n by 2, Tn by 2, like the 2 times. Divide, no comparison. Combine, 2 comparisons are there. Let's simplify. Don't write more, don't write less. If you write more, more comparisons will come. If you write less, less comparisons will come. But I want exact comparison. So what is the answer? Tn is equal to 2Tn by 2 plus 0 plus 2 is 2. Not more, not less. This is the exact answer. 2Tn by 2 plus 2. Right? If anyone write more, more will come. But I don't want more. I want number of comparisons to this program. 2Tn by 2 plus 2. Now apply substitution method. 2. 2Tn by 2 plus 2. Outside 2 there. Can you help me now? What are these 2? These divide comparisons are 0. Combined comparisons are 2. Combinedly 2. What is the meaning? Divide and combined comparisons 2. Divide, see this one. Divide and combined comparisons are 2. Divide 0 comparison. Combine 2 comparison. Overall 2. Next one. Can you help me now? Can you help me? If you simplify this, what is the answer? 2 square T n by 2 square plus 2 square plus 2 power 1. Can you help me now? What is this 2 power 1? First level, divide, combine, comparisons 2. Second level, divide, combine, comparison 2 square. Please verify yourself. Can you, how many level tree will come? Log n minus 1 tree will come. Same. There also log n minus 1, tree height is same. Because you are stopping at 2. Same height will come. But there you are finding time complexity. Here you are finding comparisons. Now let's see one more round. 2 square. 2Tn by 2 square by 2 cube. Plus 2 outside 2 square there, 2 power 1 there. Simplify now. 2 cube T n by 2 cube plus 2 cube 2 square plus 2 power 1. If you do, can you say what is this one? First level, divide, combine, comparison. Second level, divide, combine, comparison. Third level, divide, combine, comparison. If you do 3 times, this is story. Can you say how many times I should do? K time, where K is log n base to minus 1. You know, same story. Which will goes to 2 power log n base to minus 1. T of 2 plus series 2 power 1, 2 square and so on. What is the answer? It is the 3 means it is the 3. It is the log n minus 1 means it is also log n minus 1. Right? Next one, this will become n by 2. What is the T of 2? 2 elements are there. How many comparison? We written already. 2 elements are there. How many comparison? 1. Don't write constant. 1. So 1. Plus solve this GP series. A into 2 into r power 2 power log n base to minus 1 by r minus 1 2 minus 1. Don't write more, don't write less. Which will goes to n by 2 plus, right? Simplify. 2 into this is going to be 2, right? N by 2. 2 into n by 2. So n minus 2. Below is minus 1. Which will goes to 3n by 2 minus 2. right? This is the exact answer. So number of comparison using divide and conquer, this one, using divide and conquer to find out maximum minimum, number of comparisons are these many. Number of comparisons are these many. Can you see it best case or worst case or average case? Because of divide and conquer, every time same story, right? Every case. Using divide and conquer to find out maximum minimum, right? These many comparisons. 3n by 2 minus 2 comparisons. 3n by 2 minus 2 comparisons, right? Please be careful. If you want to evaluate 1.5n minus 2. Okay, whatever you got, it's okay. These many comparisons are there. So can you help? This is the recurrence relation for. This is the recurrence relation for comparisons. Next one, I written this side also. Let me check. This is the recurrence relation for time. Time means right for time. Comparisons means right for comparisons. Can you say what is the time? Theta of n every case. Because of divide and conquer, every time same procedure, no chance of minimization. Theta of n. Can you say what is the space? Because of right log n level stack. So I think extra space is log n. Extra only people will ask. Extra only people will ask. Only for namesake input I am adding. Total space is, I think everything you have to add. That's okay. But when comparison is going on, extra only will compare. Non-recursive program, if you see stack space 1, but here log n. Because of log n level. Right? Next one. Compare how many here? 3n by 2 minus 2 means 1.n minus 2 comparisons. Every case these many comparisons. Now can you help previously without divide and conquer also you done. Without divide and, this is the without divide and conquer. Can you help without divide and conquer what is the time? Everyone know time complexity for the non-recursive program loop. See, no recursion, nothing, loop. Loop is how many time? N minus 1 time. Time complexity theta of n. Here loop compulsory, so n theta of n every case, right? With divide and conquer also n, without divide and conquer also n, that's okay, right? But this one, no recursion, 1 unit of stack, extra space is 1, that is also okay. But let's come to the comparisons, let's come to the comparison, right? To this algorithm, without divide and conquer, to this algorithm, best case comparisons are these many, worst case comparisons are these many, average is going to be this much. Right? Average is going to be this much. See, n by 2, see 3n by 2 minus 1, something like that. Right? Fine. But that one 3n by 2 minus 2. Right? With divide and conquer every time 3n by 2 minus 2. But here, right? Best case this much. Worst case this much. Average is this much. But in the case of with divide and conquer, every time is right like this only. Right? If you want, you can go there. Right? This is the case. Every time 3n by 2 minus 2, but there, right? Let's see this one. This is with divide and conquer. Using divide and conquer, every time comparisons are like this. Without divide and conquer, see, without divide and conquer. Best case how many? N minus 1. Worst case how many? 2 into n minus 1. Average how many? 3 by 2 n minus 1, something like that. This is every case like this. Using divide and conquer, this is a story. Without divide and conquer, this story. We want only this. Can you say who is better? Who is better for space purpose? Extra space because of recursion, log n, then 1. Right? So let me write. What is the time here? These are the comparisons, it's okay. What is the time? Time is here theta of n. Every case. Here also same. Theta of n. Right? And one more. What is the extra space here? Extra space. What is the answer? Log n. Because of recursion. Here extra space. Because of no, right? Recursion, not the 1. So this is the final conclusion. Total story, whatever I said, is very big story because of it is the first application, right? It look like very complex and all, right? Totally 9 applications are there. Every one contains same story. Total thing one time you see.